Good morning, everyone. Am I audible?
Yes, sir.
Yes, sir. Good morning.
Morning.
Good morning, sir.
Okay. Good morning, everyone. Today's class is we're gonna start with wherever we left off last class. It was essentially we were discussing cross product. Okay.
Algebraic cross product.
Yes. So there was this one particular section left, which was part 4, and we were discussing on how we can do cross product if, uh, well, if it was given in the graphical format, then we can do it easily. You just have to worry about magnitude of A, magnitude of B, sine theta, and the direction of that cross product is given by the right hand thumb rule. And there are two variations of it. One is put all your fingers along the first vector, curl towards the second vector. The direction of your thumb gives the direction of the vector product or the answer to that question. The second type was using this, the right hand rule. Okay. I have told you to ignore whatever left hand rule you have studied in 9th and 10th standard. So there were two laws, Fleming's right hand rule, left hand rule. Please forget them. Just remember one. We are going to only use right hand, and this is the configuration that you have to follow. Okay. In here, the index finger is pointing towards the first vector, the middle finger is pointing towards the second vector, and the thumb will be giving us the direction of the product. Okay. And like I said, A cross B is not equal to B cross A. So it matters which one is the first vector. Okay. Now, second part, the part 4. Can someone tell me what is part 4?
Algebraic cross
Algebraic
product.
Cross product in the
algebraic form.
algebraic format. Okay. So in this type of cross product, what will be given to us are two vectors. Okay, I'm getting distracted. Guys, please be here by 9 p.m. 9 a.m. Okay. Uh, in between, if you're joining, I miss a beat. Okay, that's not good for everyone. So if you have two vectors and they're in the component form, this is how they will look. So ax I cap plus ay j cap plus az k cap. This is vector number 1. This is vector number 2. Bx I cap plus by j cap plus bz k cap. Okay. Now, what are these subscripts? Just to represent the components. Like usually, it will be given in numbers. Like it will be given like 2 I cap plus 3 j cap plus 4 k cap, and B will be given as minus I cap plus 2 j cap plus 3 k cap. Something like this will be given to us. Okay. So here ax, this particular x component of a vector is essentially 2. It is given to us as 2. Okay. So don't be confused on what this is. This is just a symbol to represent the x component of the a vector. Okay. X component of the a vector. Cool. Now, how do I do a cross b? Well, we'll proceed generally like we usually do in math. We'll arrange them like this: ax I cap plus b ay j cap plus az k cap, and cross multiply that with bx I cap plus by g cap plus bz k cap. Okay. Now, can you tell me how many, like if you multiply it three, like what I'm trying to say is if you have a, b, c, a plus b plus c, multiply with d plus e plus f, how many total terms should be generated in this?
9.
Nice.
Yes, yes. So if you multiply a with d, a with e, and then a with f, then we start with b, and you multiply b with d, b with e, and b with f. And this is the process, the mathematical process we follow to multiply. There should be 9 terms that should be generated here. Okay. But can you tell me there are 3 terms which are going to be 0 in cross product? Can you tell me which ones?
When I is multiplied to I, like when the same directions multiplied.
Yes, very nice. Now, if you remember the definition of A cross B is essentially magnitude of A, magnitude of B, and sine of theta, where theta is the angle between the two vectors. Now, imagine if there are two vectors in the same direction. What is the angle between them? Well, for
Zero.
for theta, for vectors in same direction, theta is going to be 0 degrees. So that means sine theta, which implies that sine theta is also going to be 0. So
Sir,
which
sir, sorry to interrupt, but isn't it supposed to be a times b into sine theta times r cap for the
yeah,
cross?
yes, I'm talking only about the magnitude. Obviously, it is going to have a direction. But in this multiplication, if this sine theta becomes 0, it doesn't really matter what else I write here. But you're correct. I should have shown the direction as well. But I was talking only about the magnitude. So for vectors in the same direction, if theta is 0 degrees, sine theta is 0, then that cross multiplication should be 0, right? So like the lady said a few seconds ago, if you multiply those terms, ax and bx, you're essentially multiplying cross product. You're trying to do cross product of two vectors in the same direction. So those terms will always be 0. I hope that makes sense.
Yes, sir.
Okay. Now let us continue this multiplication. Just put this as a note somewhere. Okay. So out of those 9 terms, we'll only be writing 6 terms only. Okay. 6 terms only. And those 6 terms is when you're multiplying ax to by. Okay. Ax by. So this is ax and you're multiplying this y. Okay. Now the question is, if I multiply I cap, because you have to understand we are also looking for r cap here. We are also looking for r cap. If you multiply I to j, what do I get? Well, for that, you need to use something called the screw rule. Okay, this is known as the screw rule. Okay. Now in screw rule, it's a very standard procedure. This is what you have to follow. You make a circle and you show the clockwise direction. You show the clockwise direction. And you also write your variables or your directions in the clockwise direction. So x, y, z. Okay, or I, j, k, whichever representation you're using. Now if you follow along the arrows, your answer will be positive. If you're going against the direction of the circle, it will be negative. Okay, so you'll write, so essentially what I'm trying to say here is, if you do x cross y, you're gonna get z. If you do x cross y, you're gonna get z. Okay, let's move forward. I'm gonna make the entire table here. If you do y cross z, again in the direction of the circle, y cross z, you're gonna get x. Okay, and if you're gonna do z cross x, you're gonna get y.
Y.
But if you go in the reverse direction of this circle, like for example, you go x cross z, remember the order matters in cross product. X cross z, you get minus y. Okay, and if you do z cross y, you get
Minus.
x. Okay, and if you go x y cross x, you get minus z. Okay, notice how x cross y is not same as y cross x. Okay, x cross y is going to give you z, but y cross x is going to give you minus z. So this is a shortcut trick that you can use to find out the direction. You can find out the direction. So in this, can you tell me what is the direction of ax by? We are
It's
essentially
along the
It's
z-axis.
positive plus k.
plus k. Very nice. Okay, so you're doing I cross j, which is essentially x cross y, and you're getting k. Okay, so can you help me fill this up, guys? Rest of the terms. So I have multiplied this term to this term. Next is plus ax bz. Can you tell me the direction of this?
Minus y.
Yes. Then what should I write next?
Plus.
Now we are going for
For A-
ayb.
Aybx
Aybx
It will
term.
be
minus
negative
k.
k,
Minus k.
We are multiplying this to this. So j cross I,
negative k.
negative k is correct. Okay, and then I go ayby. This term will be 0.
Z.
Yes, and the last term will be aybz,
Plus j.
Positive I.
positive I. Very nice. I hope everyone else needs to also participate. Please let me know if you have any doubt. Then we go for the last term here, azbx.
Minus.
Az,
So minus j.
Minus k.
Minus
yes,
j.
minus j is correct. Okay, and the second last term, azby,
Plus k.
azby
Minus I.
minus I cap is the correct. Okay, because if you're doing z, that's essentially k cap. Z cap cross y is minus x. Okay, so you're going the reverse direction. And what about the last term, azbz? Again, we know that part is 0. Azbz is 0. I hope that makes sense. Okay, so these are the 9 terms that will come out of your cross product. If you understood this, let us do this problem. Let us do this problem. Okay. I need you to try this using the same process. Now, I showed you in the general form. I need you to do it for this particular numerical.
Sir, can you show the table one, sir?
Do not use the table. This table is only for you to understand. Use this particular circle. If you're going in the direction of circle like x cross y, you'll get positive z. If you're going against the circle, then you'll be using minus. Okay.
Sir, then
So you'll put the notes
AZ
in the
dx
group,
should
right?
equal to positive j cap, right?
One by one, one by one. Yes. Karthik.
Sir, AZ dx should be positive j cap, right?
AZBX, ZX. Yeah, sorry. This should be positive JK. Yes. Anything else?
So when you put the notes in the group, the NPS group,
Yeah, I do. Every time I put the notes. But I
So
still,
the numerical value we just multiply it and the direction is what changes, right?
yes. So your final answer will come as a vector. Like this product will also come as a vector, like something I cap plus something j cap plus something k cap. Because this is a cross product means that your final answer is also going to be a vector in terms of I, j, k. Put your answers in the chat, guys.
Sir, where is the chat in a Google Meet?
Well, that is something that you have to figure out. Uh, but
Oh,
in
okay,
my
I found it. I found it. I found
okay. Come on, I need 40 answers. There are like 40 people in the group. I need 40 answers. Yes, Aditya has answered. Anyone else? Do not just copy paste. I've seen that happen because there is a bunch of wrong answers, like one after the other. So yes, I'm getting 4 answers here. Should I start doing or people are trying? Please let me know. 10% of the folks have answered.
Sir, I have a doubt.
Hmm.
So after doing, you have to subtract all the terms or subtract or add all the terms.
If they're in the same direction, yes. Harshini, this like you have given two k cap and k cap, like you have given, so you can combine them, right? Like for example, 4 k cap and minus k cap. Don't start adding I to j. I hope that is clear. Okay. We have studied scalars and vectors. You know, if there are two vectors, 3 in this direction, 4 in this direction, you cannot just do 7. You have to write 3 I cap and 4 j cap. But if you have like 3 I cap and 4 I cap in the same direction, you can add them, right? 3 plus 4 becomes 7.
Okay, sir. Thank you.
Yes, yes. Okay, and minus minus becomes plus. That is also something like minus 3 minus k cap means that's 3k cap.
Okay.
Mhm. Okay, let me solve. Yes, lot of answers are pouring in. I like, I very much like. Okay, so I'll do the normal procedure. 2i plus 3j plus 4k. I'm going to multiply with minus I plus 2j plus 3k. Okay.
Sir, do they always have to be written in the order I, J, K, or can it be like in any order?
If you write in the wrong order, no one's gonna, I don't know, blame you or something. But
Okay.
general convention is to follow the XYZ pattern.
Okay.
Like when I will write answer, I'll never do, I don't know, ZYX or something. I'll just do XYZ.
So isn't that anti-clockwise direction?
Oh, sorry. I got I got distracted. Okay. Let's do let me write IJK because this the directions are given in IJK. Okay. Cool. So the first term will be 2 times 2, that is 4. I'm multiplying this and this, and I have IJ, so that means the first term will be K. Okay. 2 3s are 6. I'm multiplying the first and the third term here. So 2 3s are 6, and I cross K is minus J. Okay, then comes the second term here. 3 times minus 1 is minus 3. Okay, and j cross I is minus k. Okay, so this is the term I was talking about. If you get minus 3 minus k, that means that's essentially plus 3k cap. Okay, you can cancel out the so again 3j 3k, this is 9. j cross k j cross k is I. See, I'm not using the table, I'm using the circle here. Okay, 4 into minus 1 is how much? Minus 4. Okay, so you get minus 4 in magnitude, and k cross I gives me minus j. It gives, oh sorry, it gives me plus j. K cross I gives me plus j. Okay, and the last term being 4 2s are 8 plus 8, and k cross j gives me minus I. Okay, so please let me know if I made any calculations. I think I did not, but this is the terms. Okay, now there's a way. I'm gonna simplify this. This is 3 plus 4 7 k cap. Okay, in terms of j, if you think there is minus 6 and minus 4 giving me minus 10 j cap. Okay, and how much is the x coefficient? Well, there is 9 I cap and minus 8 I cap. So that means this is I cap. So this is the correct answer. I cap minus 10 J cap plus 7 K cap. I think a lot of you got the correct answer. Okay. So I hope you understood. If there is any doubt, please let me know. If there is any doubt in the procedure or how to do it, sir, I didn't understand this part. Please let me know. I will explain again.
Can you please explain the last step?
The last step.
Yes.
The last step is I just did 4 cap and 3 cap. I added both of them because these are vectors in the same direction. Okay. So 4 cap plus 3 cap is how much? 7 cap. Minus 6 j cap and minus 4 j cap. If I add, this becomes minus 10 j cap. Okay. Uh, and I cap terms, 9 I cap and minus 8 I cap gave me 1 I cap. I hope, does that clear your doubt?
Yes, sir.
Okay. So this being said, this I think is a little bit out of order, so because every time you have to think which term, and if there's a chance you'll make a mistake here. There's a chance I'll make a mistake here uh, in the long run. So I'm going to teach you a small mathematical tool which you will study in your 12th standard, something called the determinant. Okay. The determinant helps us to this helps us not to, like, how can I say, uh, don't question me on how to or what are the other applications of this mathematical tool that will be taught in math. What I'm after is how to use this particular mathematical tool in our cross product. That is what we are looking at. Okay, so essentially this is known as the short short determinant method. Okay, this is the determinant method to find out the cross product in a little more organized and a slightly faster way. Okay, now what exactly determinant is, I'll tell you, and I will show you how to work with this. Okay, so let's say we are given two vector quantities. Let's say 2 x cap plus 3 y cap plus 4 z cap, and let's say b vector is given to us as minus x cap plus 2y cap plus 3z cap. I think this is the vector I took in the previous question also, so we can cross verify whether our answer is correct or not. Okay, so how do you do a cross b? Well, using this method, well, you just make this one structure, two lines in between. Okay, and you first write down x cap minus y cap and z cap. Okay, again, don't question me on the working of this mathematical tool. It will be very thoroughly discussed in your 12th standard. Right now, all you need to focus on is how to do it, rather than the questioning the existence of determinants and why determinants work like the way they do. Okay, so do not question the determinant itself, but rather learn. I don't need you to question on how you got the range. I need you to just learn how to use the range. Okay, so you write x minus y z. Now you might be tempted to question me, sir, why minus y? My answer will be don't ask. Okay, so just you have to write minus sign to compensate for the final answer. Okay, now the next, I'm doing a cross b, and the order matters here. This is the first vector, this is the second vector. Write all the values of first vector below x, y, and z. So x is 2, x is 2, y is 3, and z is 4. Again, this minus sign is just symbolic in a sense. Don't be like, sir, ye to y hai, I should write minus 3 here. No, this minus sign is symbolic here. You just write all the a vector quantities here. After that, first vector, and then after that you write the second vector. So I'll write here minus 1, 2, and 3. I hope this makes sense. Yahan tak everybody understood how to arrange the determinant. I hope everyone knows. First, no matter what, you just write x minus y z, and below each direction, x, y, and z directions, you just write their corresponding values of those vectors.
So we don't have to write the direction again when we write it below. Like
No,
we
no, no. You don't
we
have.
don't have to write
You
2
don't have.
x cap.
Yes, just the magnitudes. Just the magnitudes. Okay. Now I know my a cross b vector will have what? It will have a direction x, right? It will have a direction x. This determinant will tell you that value of x. That a cross b, after you do a cross b, you will get some x cap, some y cap, and some z cap, right? Using this determinant, you can easily find out how much is this x cap in a single step. What you have to do, there are two steps to doing this. When you are in a determinant, if you are trying to find out x cap, first step is ignore all numbers below x cap. Okay, so if you're trying to find out x cap, ignore every number below x cap. So you have ignored 2 and minus 1. What are the four numbers that are remaining? 3, 3, and 2, 4. Okay, 3, 4, and 2, 3. In here, what you have to do is you have to cross multiply. You have to cross multiply and subtract. Cross multiply and subtract. Okay. So second step is cross multiply and subtract. Okay, So if you look at the first cross multiplication, this is 3 times 3 is 9. 4 times 2 is 8. So 9 minus 8 is how much?
1.
1. Okay, so you do 3 cross 3 times 3 is 9, and you subtract 2 times 4 is 8. I hope this makes sense. The first step I did made sense. Okay.
Yes.
Yes, sir.
If there is any doubt, please ask me. I'm gonna do it many more times, so no need to worry if you didn't understand the first go. Okay.
Sir, which is supposed to come first? Like the how do we know if it's supposed to be 3 times 3 or 4 times 2?
No, it should be 3 times 3. Like you start from top and you subtract the bottom. Okay. Again, do not ask me why, because that will be again a math question. But wait for it. Okay. Again, I need you to just process the algorithm here, because it's not something that will change over time. It's just a singular process. Even if you do learn the process and not know why it works, it's still gonna help you, right? So the next term, now this is where that minus sign is going to come in handy. You have to write like this. What is the direction of minus y cap? Well, let's figure it out. Let's figure out the direction of minus y cap. Okay, so how do you do this? Again, if you are trying to find out the direction of this y cap here, ignore every number below this. You're left with 4 numbers, 2, 4 and minus 1, 3. What should I do? 2 times 3 is how much?
6.
6. And then subtract 4 times minus 1. How much is 4 times minus 1?
Minus 4. Minus
So,
4.
minus 4. Okay, so how much is this term right here?
10.
So this
6
is
plus
this
4,
is
10.
4, 10.
minus 10 y cap, because remember there was a minus sign here. Okay, 6 minus minus 4 is 10, but remember the minus sign. This was the use of, to compensate for the final answer, you have to put a minus sign in the middle one. Help me do the last one. Help me.
I thought it got.
So it will be 4 times 3.
4 minus 3.
4 minus of minus 3. That would be.
Yes.
Minus of minus 3. So that will be 4 plus 3.
Let's try it out. So for finding out z ka direction, ignore this. You start with this. 2 times 2 is 4. 2 times 2 is 4. And then subtract 3 times minus 1 is minus 3. Okay. So this gives us what? 7z cap. I think this is the same answer we got in the previous one, but in a much organized and faster way. Please let me know if there is any doubt in this.
So I used this method only to solve the question. I didn't use
Yeah,
that.
obviously.
So the first row in the determinant form will always be x cap, negative y cap, and z cap.
Yes. And actually, you can, in some textbooks, you'll find they will write like this. But at the end, in place of x cap, they will, in the answer, like when they are solving, they'll put a minus sign. Consciously, they'll put a minus sign. Because the middle row is usually compensated by a minus sign. But when I do this, what I do is I tend to forget this minus sign. So I just announce it in the beginning that the middle row's answer will be a negative answer. That's the purpose of that minus sign. Okay. Now it's up to you whether you want to write the minus sign here or not, or you can adjust. But at the end, you have to adjust a minus sign here. Okay. If you don't write a minus sign on top. But it's up to you. I prefer to use a minus sign in the beginning.
But then won't it be better if we write negative y cap before 6 minus of minus 4?
I didn't understand.
So instead of writing minus of 6 minus of in the bracket 6 minus of minus 4 times minus y cap, can't we write the minus y cap before the values?
You can.
Y cap times.
But see, usually the convention of writing a vector quantity is its magnitude followed by the direction.
Okay.
So if you write y cap 10, this is not a correct representation of vector, if you know what I mean.
Yes, understood.
Okay.
Sir, is minus 10 y cap and 10 minus y cap the same?
Yes, it's the same. Anything else, guys? Okay, so what you can do is practice more questions on this. Okay. You can take up any standard textbook that has vectors in it, and then start solving. You can go for your NCRT textbook also. There are a bunch of questions on there as well. Okay. In the last assignment, what questions? In the questions that I gave, there is also questions based on cross product. You can try them using this method. Okay. And I hope you understand that if I do B cross A, the entire process will be reversed. Like -1, 2, 3 will be written on top, and 2, 3, 4 will be written at the bottom. That's why I said that this order matters. You always have to do the top cross multiplication first, followed by the bottom one, and then subtract. Okay. So that's why because the cross product order matters, that's why you have to do like that. I hope that made sense.
So can you move the screen up a little bit? I want to take a screenshot.
I'm gonna share the notes at the end of the class. Okay. So no need to take screenshots and everything. I will send the notes after class in all the respective groups. Okay. So no need to worry. Okay. But that being said, please write notes as well, because when you write notes, it essentially registers in your mind. Okay. Okay. So this is now going to be a new topic in today's class. I'm going to talk about, I should not be using yellow color. Although it looks good, it will not be visible in a white page.
It's a dark black page.
Say what? Okay. So today we are going to do a new topic. This is known as constraint relationships. Okay. Now let's start from the beginning. What exactly is the word
Sir,
constraint?
did you miss an S in this?
I did miss an
Heading.
S. I did miss an S. Sorry. Constraint. What does the word constraint mean to you in everyday English? What does it mean?
So restrictions.
Restrictions or limitations. Okay. So that is also true. Like for example, in chemistry also, you might have, if you have studied mole concept by now. Imagine I give you an example. Ki banana milkshake's standard recipe is 1 banana. Okay, 1 banana, and I think this is how you make a banana, and 1 glass of milk. This is the standard recipe for banana milkshake, and I give you 10 glasses of milk and 12 bananas. How many glasses of milkshake can you make?
10.
10.
10. Why? Because the constraint here is the glass of milk. Okay, that is what is governing this particular recipe. This is what is governing this particular reaction. This is what is governing this particular motion. Okay, so in chemistry, this becomes the limiting reagent. If have you done this in chemistry?
Yes, sir.
Yes, sir.
Yes.
Yes. In chemistry, this becomes the limiting reagent. In physics, this becomes constraint relationship. Okay. Now the concept here is same, but we are dealing with what? Motion. In physics, we'll be dealing with motion. Motion is governed by 3 parameters in physics. Displacement. Okay. Velocity. And guys, tell me.
Acceleration.
Acceleration. Okay, so these are the parameters that will be put under constraints because of an external agent, because of a limitation. Okay, so that kind of motion is known as what? This is known as the constrained motion. Okay, now let us take the most easy example of all. Okay, let me turn my magic shapes on. So if I do this, I get perfect squares. Yes. So imagine there are 2 bodies that are kept separately If this is moving with 5 meters per second, what is the velocity of this block? Well, it can be anything. I could have this as traveling at 10 meter per second. I don't know, 2 meter per second. There is no constraint because of A on B. Does this statement make sense? There are two blocks kept on the table separately. A is moving with 5 meter per second, B is moving with 2 meter per second or 3 meter per second, whatever velocity. So there is no relationship between VA and VB. There is no relationship. Okay.
Sir, if they're on the same line, they'll eventually meet, right?
Yeah, they will.
So then
But
there'll be constraint.
yeah, then there will be constraint, but no, not that far down the line, right? I was talking about that particular instant. There was no constraint because of A or B. Okay. So let's say again the same scenario, but this time, okay, why is my magic shapes not working? What did I do?
So could you tell us the definition of constraint?
Definition of what?
Of constraint, like
Like that's something that you understand. I'll give you the definition in a bit when you understand the stuff that is going on. Okay. So wait for it. Just give me a few seconds. So this is block A and this is block B. Okay. And block B, A and B, now this time they're tied with a string. These are tied with a string. Okay. And in physics, strings are usually unbreakable. They will not break. Okay. And whenever they're talking about strings, they should also not slack.
So that's theoretically right. Not
yes. Obviously. Have you seen a string that's unbreakable? Maybe made of vibranium. I don't know. But in normal life, strings are breakable. But in physics, when they say ki block A and block B are connected using strings, usually it means the string does not break. Okay. I hope that makes sense. Theoretically, yeah. Okay. So A and B blocks are kept on the floor, and they are essentially, they are essentially tied with a string that is essentially unbreakable, and it is not allowed to slack. Now, if block B is traveling with 5 meter per second, if block B is traveling with
So
5
what do you
meter
mean
per
by
second,
slack in this case?
huh?
What do you mean by slack? You know, right?
We'll talk about it. Give me a few seconds. I'll talk about it. So if B block is moving with 5 meter per second, find out the velocity of block A. Can we find out the
5 meter per
velocity?
second.
5 meters per second.
5 meters per second.
Does everyone agree with me when I say block A is traveling with 5 meter per second?
Yes, sir.
Okay. Because two things. Imagine if block A was traveling with 2 meters per second. The distance between A and B would increase after seconds, right? Because after 1 second, B block is going to travel 5 meters in this direction. However, A block has only moved 2 meters. So the distance between A and B has now increased. But the length of the string is not allowed to increase, or it's not allowed to break. So that means the velocity cannot be less than 5 meter per second. Now imagine the other scenario. What if this thing was traveling at 10 meter per second? This thing was traveling at 10 meter per second. What will happen to the distance between A and B?
Sir, after 1 second, the object A will overtake object B.
Well, we don't know the distance between them. What if the distance between them is
So the
100
string is
meters?
not allowed to slack.
It
So
will reduce
it-
at
But there will be slack.
Why? Because it's not allowed to slack.
This is why I think this will make clear whoever was asking about
so
the
the
slack.
block B will accelerate and block A will decelerate little bit.
So this thing has come by a distance of 10 meters, but this thing has gone only by 5 meters. So the distance between
Will
A
reduce.
and B has decreased. So that means the string will somehow become like, I don't know, like this.
I know the answer. The string becomes shorter.
No, it does not. It is not a stretchable string. Okay, it does not become shorter, but it does not slack. That is not allowed in physics, that strings slack. Otherwise, there's no point to the constraint. So now I'm going to say a few things, and this is something, few things that you need to understand. The first thing we did in this analysis is that we understood the the first thing is that the string is acting like a constraint. String is the constraint, or rather I should say the length of the string. Length of the string is the constraint. Okay, this is the constraint that is governing the motion of A and B. Okay, the length of the string being constant and is not allowing for block A to move at a faster or slower speed like other than 5 meters per second. It cannot be greater than 5, it cannot be less than 5, because of the fact that the length of the string is constant. Okay, the length of the string is acting as the constraint, as the limitation in this particular motion. Okay, second thing I understood is that velocity of A is equals to velocity of B. This is a mathematical relationship between velocity of A and velocity of B. Okay, this particular mathematical relationship is known as constraint relationship. Constraint relationship. Okay, this mathematical equation, one second, let me complete and then I'm gonna ask you to ask out. So when I say VA equals to VB, and remember in physics there could be, if you involve pulleys and wedges and everything, you can have very fancy mathematical equation. VA equals to 10 times of VB, okay, or VB equals to V by 10, or you can also involve sine theta, cos theta, all sorts of things can happen. Okay, but the ultimate mathematical relationship that will govern the velocities between two bodies is known as the constraint relationship. Yes, ask.
Sir, since the string is not slacking, that doesn't mean it acts as a rod. It's not allowed to slack, so it can act as a rod, no sir, in a state. So if A velocity increases, won't it be like pushing B?
See, you have to understand, when I say it is not allowed to slack, if it slacks, it defeats the purpose of a string. Now, rods are something that can apply compressive stress, which you are absolutely correct. If you try to increase the velocity here, block B will also will have an increase in velocity. Okay, but if it's a rod, then they will tell you it's a rod. Okay, in that case, moving A with a higher speed will actually impact B. But in this particular scenario, velocity of A is dependent on B, but B is not dependent on A. Okay,
yes,
I hope that makes sense. Okay,
yes,
so the constraint of B is on A, but A is not applying any constraints on B. If it was a rod, if there was a rod between A and B, then yes, both of them would be applying a constraint on each other. Yes, other doubts? Nice doubt. Other doubts, guys?
So why is there no constraint relationship for A on B? Like you said,
Because it's a string. If you move this, like for example, imagine a scenario, the string between A and B, and a block behind you push it. What will happen? Will block B move? No. Like unless it goes and touches it, that's a different scenario. But if suddenly this starts with 5 meters per second, it doesn't apply any constraint on B because the string will simply slack.
Sir, I will pull the block A.
Huh? Then if you pull the block A in this direction, then A starts applying constraint on B. But all of this is, I think, common sense. I think I don't need to explain every part of it. But yes, you guys are thinking in the right direction. Okay. All the cases will go through.
So what would happen if block B, the velocity of block B decreases? Then the constraint will be gone, right?
Yeah, then the constraint will be gone.
So it means that A also puts a constraint on B, and B also puts a constraint on A. If both them move in like opposite directions, right? If I pull B, then there'll be a constraint on A.
Then they'll take the net velocity.
See, the thing is, their velocities will always be same. Like if they are moving in with a constraint. But yeah, if B is moving in this direction, it will apply a constraint on A, and it will say A also come in this direction. If A is moving in this direction away from B, so that is the scenario. Yes. So I get what you're saying. Yes, any other doubts?
So will the constraint relationships also apply for displacement and acceleration? Is there some for that as well? Equations.
That is what I wanted to talk about next. Is whatever constraint relationship holds true for displacement. Okay, and this is a note. Please note it down. Whatever you, I'll write it down. Okay, so whatever constraint relationship holds true for one parameter of motion holds true for the rest of the parameters. Okay, for the rest of the parameters. Now that means if you have identified that VA equal to VB by doing some analysis, you can simply say displacement of A will also be equal to displacement of B, and acceleration of A will also be equal to acceleration of B. Okay, now this is something that you have to take for granted now, and later on I'll explain. I hope everybody has written this. Let's move forward. Okay, let's delve deeper into this particular concept of two blocks being attached by a single string. Okay, now one thing you need to understand here is that we are not putting a constraint on the bodies themselves, but the points attached to body A and body B. Okay, the points on the string, like essentially because the length of the string is the constant, right? The length of the string is the constant. So because they're attached to the blocks also feel the constraint, but ultimately point A on the string and point B on the string should be displaced by same amount if the length has to remain constant. So if A point goes in this direction by X, B should also go in this direction by X, then only A to B length will always be constant. Okay, so that is the idea here. So while doing this, you will notice that at any instant, and this is the key word here, at any instant, if I have a velocity like this, okay, you have to understand that this velocity will have two components. Now, taking components you have studied in the previous class. Okay, this point, if point A is not, along the string or perpendicular to the string, it's at a random location theta, this velocity is actually made up of two components. One is along the string like this, which will be how much, guys? Tell me, this will be how much? Let's call this V. This is how much?
V cos theta.
Towards theta. Everybody forgot previous class or what? Towards theta, cos theta. Towards theta.
I just
Cos
away
theta
from
and away.
away
Sin
from
theta.
theta, away from theta.
Sin.
Okay, so the
So
velocity
I
is,
accidentally left the meeting. Could you explain the last 2 minutes? Sorry, sir.
yeah, okay, I'll repeat one more time. So if you have two blocks, the constraint is actually not on the blocks but actually on the ends of the string. So here I'm talking about the ends of string here, the A or B. And imagine a scenario when the velocity is not like perfectly given horizontally. It is given, let's say, at an angle theta. So it will have two components. One is the cos theta component, the other is the sin theta component. Essentially, one will be a component which is along the string. This is the component along the string. Okay, and this is a quantity, or this is a velocity which is perpendicular to the string. Okay, Now the distance between A and B has to remain constant. Which of these two velocities is going to play a role?
So two velocities as in?
One is v sine theta and one is v cos theta. I broke the original velocity into two components. One is the v cos theta. Now essentially v is no longer there. I broke that velocity into two components. One is along the string, which is v cos theta, and one is perpendicular to the string, which is v sine theta. At this instant, which of these two velocities is going to affect the length of A to B?
V cos theta, I think.
V cos theta or v sine theta? Which of these two velocities are going to affect the length of AB? Please, everyone, please respond.
V cos theta.
V cos t.
Exactly. Yes, v cos theta. V cos theta is the component, and I don't know why everyone suddenly fell silent. Let me quickly revise this. If you have a vector in a certain direction and this is theta, this vector can, in physics, we cannot analyze vectors like this. This is very difficult to analyze vectors like this. So that's the reason I taught you the whole component form. You can break this vector and you can think of this like one vector going in this direction as v cos theta, and towards theta is v cos theta, and another vector going perpendicular to it, and that will be equal to v sine theta. If you're not revising your previous classes, let me tell you, it's going to affect you. This is the third class and you'll feel the repercussions of not revising the second class, because today's class is going to involve a lot of component taking. So if you didn't revise, take it as a lesson, because it's going to hurt. Today is going to hurt if you didn't do the revision for previous class. Okay. So from this discussion right here, I'm going to make a conclusion. Okay. So the conclusion is this: the component of velocity along the string is going to be same for both the bodies. Okay, like you agreed with me, if the bodies have some v sine theta, we are not worried about it, because v sine theta is not going to affect, it's not going to affect the length of AB. The constraint is along the string, because the length of the string can only be affected by v cos theta, not by v sine theta. Okay, so that is why the constraint will be on the direction along the string. Okay, so like here, the velocities that I gave were already in the direction of the string, so you didn't have to worry. Okay, but the next question which I'm going to talk about is a scenario when you and again, this is not going to be a side view. Okay, this is going to be a top view. Okay, this is a top view. I have block A. I have a block A like this, and I'm looking from top. These are two blocks kept on the table and I'm looking from top. Okay. Okay.
There is a string extendable.
No, strings don't extend. Let's start with the easy one only. Let's not make it too complicated in the beginning. Okay, so let's say these are two blocks, block A and block B. They're attached by a string, and we're looking from the top. By the way, we are not looking from the side. There's no ground below this. There's no ground. We are looking. There's a table below this, and we're looking from top. And when I'm looking from top, I see that this block is moving like this. Okay, its velocity is VA and its angle is, let's say, theta here. This angle right here is theta. Okay, and you know what, I'll give you values. This angle here is 30 degrees. This is 10 meter per second. This is 10 meter per second. Block B, I don't know what the value is, but it is moving like this, and the angle it is making with this forward direction, is actually 60 degrees. Okay, 60 degrees. You have to find out what is this velocity VB. Please find out what is velocity Vb. I hope everybody understood the question. There are two blocks kept on the table, and this is the top view. This is the top view. I'm looking from top. Okay. Now I see one of the blocks moving with 10 meter per second at an angle of 30 degree with the forward direction. Similarly, B is moving at an angle of 60 degree in the forward, 60 degree to the forward direction with certain velocity Vb. Figure out how much is Vb.
10 root 3 meter per second.
Yes, please type your answer in the chat. Your voice is not very clear.
So I didn't understand how to solve it. Like, I understood the question. I didn't understand.
Okay, cool. Give me just allow everyone to try once. I'm gonna give you 2 minutes to try this. Okay, I don't see no chats, but everybody is waiting. Oh, I see one. Okay, let me explain. I already did though.
So-
Let's. Yes.
So will it be the same as the sign? Will it be same as A?
No, VA equal to VB was not the ultimate constraint relationship on a string. Okay, that's why we are doing this kind of analysis. This analysis showed us it's not V sine theta is not going to have any effect on the length of the string. So when you say VA equal to VB, you're also implying this V sine theta should also be equal to V sine theta. That has nothing to do with the length of the string. Why will you put a constraint on a velocity which is not having any effect on the length? Okay. So the component of velocity along the string is going to be same for both bodies. That is the constraint on situations like this. Okay. So again, you have to break it into two components here. One velocity, like 10, the body is going 10 meter per second in that direction, but in the forward direction, what is its component? The body is going with what velocity in the horizontal direction?
5 root 3.
Yeah, yeah, that is correct.
V cos theta.
V cos theta, which is essentially 10 cos 30. Now cos 30 is what? Root 3 by 2. So that means this velocity is going to be 5 root 3 by 2. So that means, 5 root 3. So that means this body is actually traveling in the horizontal direction with 5 root 3, and it is going upwards with what velocity? It is going with 5 meters per second. It's going with 5 meters per second. How do I know this? 10 cos 30 and 10 sine 30. Okay. Similarly, this block right here is going to have two components. One along the string, which will be like this, which is VB cos 60. How much is VB cos 60?
5.
VB.
No, that's VB by 2. Where did 5 come from?
VB by
I
2.
tell you VB is 10. This is VB sine 60. So VB root 3 by 2. Okay. Now again, my question is again the same. Is perpendicular velocities, these velocities, can we constrain them? No, they are not playing any role on the length of the wire between A and B. So definitely we are not going to put any constraint on them. We are not going to put any constraint on these velocities. We can only put a constraint on these velocities, the velocity of these bodies along the string. Okay, along the string. So I can say that VB cos 60 is actually equals to 5 root 3. This is what I can say from this discussion, is that the length between A and B is dependent on velocities along the direction of the string, not perpendicular to it. So you cannot just say sir, VA is equal to VB. And you can also imagine that if you try to move A in that direction or something like that, B will not move. Okay. Or the string will essentially slack. Okay, if VB was also equal to VA. Okay, so you can only put a constraint on the horizontal direction, and the constraint being the length of the wire being constant. So VB by 2 is going to be equal to 5 root 3, and therefore VB comes out to be 10 root 3. Okay, so your answer is 10 root 3.
So a meter per second, right?
Yes, meter per second. Any other doubts, please let me know. If there are any doubts, please let me know.
Sir, if you have two blocks attached by a string and you lifted up one block, then would you not move the other block?
You would, but that's a different kind of constraint. You're saying that one block is like this, and the other block is essentially like this, and you're lifting this, yes?
Yes, sir. It's only vertical component, so theoretically the other block shouldn't move, right? But then obviously
Yes,
it
and
moves.
this, see, the we are discussing at every instant. If you suddenly increase or put a velocity into this, this will not have an instantaneous velocity, if that makes sense. At this instant, this thing will not have a velocity. But as it keeps on going up, you know the length of this is going to be constant. The length of the string is going to be constant. So eventually this will be forced to move in this direction. But that kind of constraint will be taught in further classes, okay, further lectures. This right now we are talking about only at an instant, at this particular instant. The perpendicular components of the velocity is not going to affect the uh, length of the wire.
Okay.
Yeah. Yeah. मैं और उनके लिए गया टोटली दूसरी ठाकुर से okay, so I hope everybody understood this. If there is any doubts, feel free to ask. Okay, let's, if there's no doubt, that let's move on to the next topic here. Okay. Okay.
Sir, but then shouldn't the answer just be 0 because the string will slack?
What?
In the previous question, shouldn't the answer be 0 because at that instant it wouldn't move?
No. See, the thing is, it's already given to us that there is a VB which is causing the length of this wire to be constant. Okay. Now, if you're saying that this velocity is 0, that means there will be slack, no? If this was traveling with 0 velocity, then definitely that thing going at 10 meter per second in that direction will create a slack here, no?
Oh, so the block B is pulling the block A along.
The cause is not like the question here, which is happening first, which is happening second. Obviously, we know we're talking about a scenario when both of them are happening simultaneously and the length of this thing is to be constant. Okay, so the question is something like this: VB is going at a certain velocity such that the length between A and B remains constant. The length of the string remains constant. It is neither slacking nor breaking. What should be the velocity of VB? How it started or which is pulling who is not going to be an like, it's in physics overall. Till we reach Newton's laws of motion, it's never gonna be a question on what is causing or what is the cause of that motion, because the cause of the motion can only be discussed when we talk about the forces involved and the tension forces and the normal forces which are involved here. Okay, so right now we are only considering the fact that, okay, this thing is moving. If this is moving, then what velocity should it move such that the string between them remains constant? But yes, I think your analysis is correct. You're saying, sir, if A moved in this direction, B will not move because of any constraint directly. So yeah, that is also true. But understand, we are not talking about who is causing what motion. We're talking about B is already moving, A is already moving. What should be these velocities so that the length of the string between them remains constant? It's neither breaking nor slacking. I hope that makes sense. Does that clear your doubt?
Yes.
Okay. Next discussion is going to be on pulleys. I don't know how many of you have seen this in real life. Okay. Uh, well, ooh, if you have gone to any construction site where they're lifting up heavy things, then definitely you might have seen this. This is a pulley system. Or pulley system usually has it's fixed to the ceiling. Usually it's fixed to the ceiling. Okay, and you have a rope going from this side, and then a rope going from like you pull in this direction, and this thing goes up. This thing goes up. Okay, so that is the scenario. Now, if I have the most basic pulley like this, okay, one is like this. Trying to make straight lines here. This is a very standard pulley here. This is block A and this is block B. This is the next type of problem we are going to
So,
discuss.
can you give a real life example of a pulley?
1 second. Let me Google this. Real life pulley pictures.
So it's used in the village wells.
So
Yeah, village. Yes, village is where it is used to.
In the wells,
So,
we
a
use.
well is an example of pulley.
Yeah.
Okay.
Do you see real life examples of pulley? Do you see this on my screen?
Yes, sir.
Okay. One more real life example. I shall copy and paste.
There are a lot of gym equipment.
Yeah, a lot of
Yeah.
gym equipments also has pulleys.
Yes, these are also pulleys. Okay. Gym pulleys pictures. Pictures. Mhm. Okay.
So come to think of it, if you have
Yes.
blocks in free space attached by a string,
Yes. This is
then
the pulley. Focus here. Yes.
anyway, can I ask another doubt or do we? I
So
don't know if we
let's.
have the time.
Is it relevant to this topic? Then yes, please.
It is not relevant to police. It's relevant to the previous question.
On the previous question. Let's keep it to the end of the class. I'll stay back. We can have a discussion. Yes. Someone else was trying to ask something or say something. I don't know. Let's move forward. So the basic question here I wanted to ask is that I hope someone was asking for real life example. I think you got real life example. Okay. I hope everybody knows what a pulley is. You put a string over it and you do a bunch of stuff. It reduces the effort of doing things. So my question to you is this: if this thing goes up by 1 meter, if A block goes up by 1 meter, how much does B block come down by?
1 meter.
1 meter.
1 meter. That's really easy, right? So if you have a pulley like this, then yes, this is the scenario. If this goes up by S, this comes down by S. So that means S of A, S being representing displacement here, is equals to displacement of B. But whatever constraint relationship holds true for A, displacement holds true for velocity as well as acceleration, right? So VA becomes equals to VB as well. So if this A block is traveling upwards with 10 meter per second, then B block will come down by 10 meter per second. Similarly, acceleration also. Okay. So if block A is going up with 5 meter per second square, B will come down by 5 meter per second square. I hope that made sense. This is the constraint relationship here. SA being equal to SB. Okay. But always remember, this is the most simplest case. What if everybody noted this down?
Yes, sir.
Okay. Let's do a slightly more complicated case where I give you this. So let's say this is a floor, and at the end of the floor there is this another floor. So this one floor, this floor number 2. Okay. Now at this junction right here is a small pulley. Okay. Over this pulley, and let's make blocks with some different colors. This is block number A, and it's in contact with the floor, and this is going like this. This is a string that goes like this, Okay, and there is this another block here. This is block B. Both the blocks are in actually in contact with the ground. I couldn't make this to be in contact, so I'll try one more time. Now it makes more sense. And also the string is going over the pulley. I'll try my best to make a proper diagram here. It doesn't really matter where this is touching. Okay. So this is the scenario with us. This angle right here is going to be, and I'm gonna, this is first class. This angle right here is 37 degrees. Okay. So go ahead. Tell me, if I pull this block by a speed of 8 meter per second, 8 meter per second, what will be the velocity of B? We're going into the realm where you'll start needing a little bit of critical thinking here to solve questions. Okay. So let's see how many of you can get this. It's going to be slightly difficult to answer. Okay. People who forgot the trigonometric ratio of 37 degrees, please make sure to make this small triangle in front of you. Okay. If you have a right triangle with the, oh, sorry. Why do I have, never mind. This is, if this is 37 degree, this is this triangle. Okay. So I think you already know trigonometric ratios for a lot of things. I need you to remember something extra. Sine 37 degrees is actually equal to 3 by 5. This is another trigonometric ratio that you have to remember. So that means, guys, how much is cos 37?
4 by 5.
4 by 5.
4 by 5.
So
okay?
does it really matter where the string touches the block B?
No, it does not. Sine 53 will be how much, guys?
4 by 5.
And how much will be cos 53? It will be equal to sine 37, right? So it will be 3 by 5. So I think you know a lot of trigonometric ratios. Please add these values also to your memory. Okay. If you got the answer, please put it in the chat. Gonna give you 2 minutes to try this. This is a beautiful question. Small hint will be velocity of the bodies along the string is going to be constraint. You cannot say B will also move with VA. VA equal to VB, you cannot say. Velocity of the bodies along the string is what we put constraints on.
So V, like the velocity A is moving in like straight direction only, right? It's not.
Yeah. One more thing we know for a fact. We know for a fact is VB is going to travel in the horizontal direction. Okay, this is also given in the question. I think I forgot to mention this. Okay. So unless they say this is gonna lift up, you have to consider that VB is going along the floor. Okay, so this is VB. Five by 2, 10, 10, 10, 8, 8. I think there is a fight between 8 and someone also said 2.5 meter per second. More answers, guys. There's only like literally 5 answers among 40 people. What is this? Are you guys, why are you not participating? You need to participate as much as you can. Wrong answers are more than, I'm more happy if you're making wrong mistake. If you are giving wrong answers, that means you have a tendency to learn, or you have an opportunity to learn. I don't know. Never mind. So if I want to find out the velocity of this point, which is attached to this thing has 8 meter block is going 8 meter per second. So that means this string is going in this direction with 8 meter per second. So I know the length on this side of the pulley is actually going in the forward direction with 8 meter per second. Okay, no need to worry about that. However, if the block is moving, VB in this direction, it will have two components, guys. It will have two components. One will be along the string like this. Again, you can resolve the vectors in any direction you want, but you should always resolve one along the string and one perpendicular to the string. Only then you will be able to solve this problem. Okay. So can someone tell me what will be the component of the velocity along the string? Well, it will be towards theta is cos theta. So that will be VB cos 37. And this will be VB sine 37. Okay. So from here, you will say, okay, sir, VB cos 37 is essentially the velocity of block B along the string. And this should be equals to 8 meters per second. Now, cos 37, by the way, is 4 by 5. So VB into 4 by 5 gives me 8. So that means VB comes out to be 10 meter per second. Okay, this comes out to be 10 meter per second. So yes, whoever says 10, guys, you guys are correct. Okay. Okay. So that means block B needs to travel with a velocity that is equals to 10 meter per second for the string to not break. I hope that made sense. I hope that made sense.
Sir, but then as the angle changes, the velocity also changes.
Yes, at this particular
My answer
instant,
is
10
superior.
meter. As it goes further and further, the angle is going to increase. So at different instants, you'll have different velocities of VB. But at this instant, for the string to be, again, we're not talking about a cause here. Okay. At this particular instant, if the string is to not break, if the string has to not break or slack at any point, then VB has to be equal to 10 meter per second. At the next instant, yes, the angle is going to change. Everything is going to change. Maybe the block might lift up. But at this instant, this is the particular scenario. Now, there is going to be a huge mistake that people are going to do in this, and people will also not know what is wrong with that particular approach. Okay, let's figure that out. Okay, so let's figure that out. Okay, and I'll tell you why it is wrong. So hopefully next time you, why does this say ISIS? Okay, never mind. So let me just copy the diagram one more time here, and let me talk about it. Let me talk about this. Okay. So what people will generally do is this. Sir, this particular point is moving with 8 meter per second in this direction. So that means it is, I'm 100% sure that this point will also move in this direction with 8 meter per second. Well, that is correct. Okay. This point right here should move in this direction with 8 meter per second. Otherwise, the string breaks. Now, they will say that the component of this 8 meter per second along the horizontal, if I resolve this 8 meter per second in two directions, one like this and one like this, what are the two components? Well, I'm going to make it slightly in a different location here. So this is 8 meter per second like this. If I break it into components, one component will be along this, and this angle being 37 degrees means that this is going to be 8 cos 37, which is how much? 8 times of cos 37 is how much?
So it's 6.4 meters per second.
Huh?
I did it this way only, so I got 6.4.
Huh. And the other one would be like this, 8 sine 37. And this will be equals to how much? 8 times 3 by 5. Okay. Guys, tell me what is wrong with this approach. By
Not
this logic,
necessarily wrong if the string is if the string is pulling the block fast enough that the block actually lifts up, then it's right only.
no, I do not agree. I do not agree with your. Can someone else try? Tell me why is this wrong?
So because the string is not moving along that axis, it's moving along the VB axis.
Yes, that is the correct explanation.
So can you repeat the question? What did you ask at first? I couldn't get that.
The question is this: ki the block was moving 8 meter per second in the left direction, okay, and the block B is allowed to move only along B. That is given in the question. It's moving along the floor. So while solving this is 8 meter per second moving in the left direction, means that this point on the floor uh, uh, will also travel 8 meter per second in that direction. Okay, that is what the student says, and then he takes a component of 8 meter per second along the floor, which is 37. So 8 cos 37, and he says the velocity of the body B is going to be 8 cos 37. So 8 times 4 by 5, which is 32 by 5 and 6 point something. So what is wrong in this approach? That is the question. And someone answered it correctly. Well, the question itself says that block B is allowed to move only VB. That is something given in the question, and we don't, like, unless you trust the question, or when you're solving a question, you are not supposed to break the given conditions. Now, if they didn't say anything about velocity of VB, or they didn't put any constraint on the movement of VB, ki haan, VB can move up also and it can lift also, then yeah, then yes, that could have been an answer. This could have been an answer. But right now we know ki VB is moving along this, but along, according to this analysis, this point right here is moving along this, so the block has to move not on the floor, it will move like this with 8 meter per second, and then you're saying ki, haan, the component of that velocity along the horizontal direction. So you're taking essentially the the component of a velocity, uh, which is not this is not the original velocity of the point. The original velocity of the point is VB, and component of that velocity along the string can be 8 meter per second. Okay, the component of the original velocity along that string can be equal to 8 meter per second, because in the question it was told that the block was moving in the horizontal direction with VB. That was something that was given in the component. So this approach is wrong. This is a wrong approach. Okay, so do not repeat this. Okay, do not repeat this. First, identify what is given in the question. First, identify what are the constraints that are given in the question. You cannot directly start solving by assuming a lot of things. Ki, haan, maybe this is going here, it's going up. First thing is to identify what are the given situations. That's the first. That's where the most students make mistakes. Okay, first thing you need to identify is what are the given constraints in the question. Next question also, please be careful. I'm going to give a question, so please, when you, even if you write this, please note that this is a wrong approach. This is a wrong approach. Okay. Next thing is this. Guys, try this question. I think this is pretty self-explanatory. Okay, we have two bodies. We have two bodies attached to a pulley, and at this instant, when the angle is 37 and 53 degrees, the acceleration of body A towards left is 10 meter per second square. Both the blocks are to move along the floor only. Tell me what will be acceleration of B. This
Plus
time I'm
6 meters per second.
I don't want fast answers. I need accurate answers. I think 6 is not correct. Please try again. I don't need fast answers. I need accurate answers. Think about the problem. Yes, guys.
So is it 25 by 2?
Close, but not quite correct. Please try, everyone. Please try, everyone. $7.5 is correct. Okay. I think one of you got the correct answer. Nicely done. Okay. So if I want to take components, okay, of the original acceleration in the given directions, okay. So first of all, let's see if this point which is attached, which is essentially attached to block A, is traveling with a 10 meter per second square in this direction. If I take components of that, so let me make it like this. This is 10 meter per second square. Okay. So along the string will be this direction, right, guys? This is the direction along the string, and this is the direction perpendicular to the string. Okay. Can you tell me how much is this angle? Well, if I complete the triangle here, this angle is going to be how much?
53.
This angle is going to be 53 degree. And since you know what, I'm going
Barely
to
30 centimeters.
so I want to make it here only, so that's why you know, that will make it more clearer. This point is moving in this direction with 10 meter per second square. So that means its component along the string will be like this, and perpendicular to the string will be like this. So how much is this angle? This is what I was asking. How much is this?
7 degrees. No, 53 degrees. 53 degrees.
53.
Vertically opposite angles. Okay. So can you tell me what is the what is the acceleration of block A along the string? 10 cos 53 towards theta cos theta, right? Yes or no?
Yes, sir.
So can you like repeat acceleration? No?
See, ultimately we are putting constraint on velocities and accelerations along the direction of the length. Does this statement make sense? Because I've been telling this like 3 times. So I want to know if everyone is comfortable with this statement. The velocities and accelerations and displacement, whatever parameters, we are not concerned about this velocities of the bodies. We are concerned about the velocity of those points along the direction of the string. Does this statement make sense? Yes, no?
Sir, can you repeat what you said?
Okay, 1 second. Do you remember writing this statement here? The component of velocity along the string is going to be same for both the bodies. Do you remember writing this?
Yes, sir.
Okay. What I'm trying to say here, and this is the again same concept I'm using here for A and B. Okay, A and B. If if you're ever given any random velocity which is not along the string, you have to always resolve these vectors along the string and perpendicular to the string. And only V cos theta is going to play a role and not V sin theta. This I've been telling from the beginning of the class, and this is what is going to happen here. This is going to happen here also. 10 meter per second square is running horizontally. It is not along the string. This is the direction of string. Are you with me till here?
Yes, sir.
This is the direction of string. Okay, so along the direction of string, if this angle is 53 degree, what is the component of this particular acceleration along the string? Please tell me. Previous class, towards theta.
Cos theta.
Cos theta.
So this is going to be how much? 10
cos theta.
cos
53.
How much is 10 cos 53? Well, cos 53 3 by 5. So 10 into 3 by 5. Giving 6 meters per second square. So that means along the string, I don't care how much it's going in this direction. I can find it out. I can find it. You know what? I'll find it out. This is actually what? 10 sine 53. And how much is sine 53?
4 by
5. So this is essentially going up by 8 meter per second square. But I don't care. Why don't I care? Because in the beginning only I'm telling you it is the component of acceleration slash velocity slash displacement along the string which is going to put a constraint, not the one perpendicular to it. Tell me if this makes sense. This is of no use to me. Tell me if this makes sense.
Yes, sir, it makes sense.
Okay, now let's talk about the components of this acceleration AB. I know this point which is attached to block B is going to have again two components, one along the string and one perpendicular to the string. Now this is a vector that is going like this. So wait 1 second. Let me draw it like this with a white color. This point is going in this direction with acceleration AB. Okay, can you guys tell me how much is this angle?
37.
This angle here is 37 degree. Absolutely correct. This vector right here is going to have two components, one along the string like this, right? You're with me till here?
Yes, sir.
And one perpendicular to it. Along the string, what will be the component? Please tell me.
6.
AB
Okay,
cos
right.
37 or sine 37? Cos 37.
Cos along the string.
Cos 37. And this is going to be how much? AB sine 37. Which of these two components am I worried about? Am I worried about AB sine 37 or AB cos 37?
AB cos
37.
Cos 37. Why? Because of the same statement I've been saying for all the questions. It is the component along the string that I'm worried about, and that is going to put a constraint on the length. The perpendicular component is not going to play any role here. How much is AB cos 37? Well, it's AB times 4 by 5. Yes or no?
Yes, sir.
Yes, sir.
Okay. So what do I say? Along the string, the velocities, acceleration, displacements need to be same, right? Because the length is supposed to be same. So you're gonna say, ki, sir, AB into 4 by 5, whichever we have found the acceleration along the string
equal to 6 meter per second square.
See, awesome. So from here, AB comes out to be 7.5 meter per second square. Okay, this comes out to be 7.5.
So if we draw the perpendicular on the other side, is it fine? Like for the VB, so I drew, instead of drawing the perpendicular towards the left, I drew it on the other side.
Nah, usually the components will break in only one pattern. Like for example, if you have something like this, it can only be broken down into two directions, like this and like this. So if your direction is correct, but you cannot break it like, I don't know, something like this and this and this, because if you add these two components, your vector will never come out to be the original vector. Does this make sense?
Yes, sir.
Okay, so unless your direction is same, like you can make it here also, like this, but the direction should be same. Okay, but I don't know how you made it, so you can send me a picture probably, and then I can tell you whether it is correct or not. Okay, so I think some issues with the angles Aditya was talking about.
Yeah,
I think it's resolved. So if anyone has any doubts, again, let me ask you one thing. Can I do like this? Sir, this thing is going down by 6 meters per second square. So that means this point here will be coming up by 6 meters per second square.
Yes, sir.
So I'll take a component of 6 along this horizontal direction, and it will be 6 cos 37. Will I do like this, or is it a wrong approach?
It's
So this
it's
is a wrong
wrong.
approach.
Why is it wrong?
So because you're finding for the horizontal and not along the string. So
See, the thing is, again, the concept here is again very similar to previous question. You cannot say that the point here goes up by 6 meter per second. It is not going up by 6 meter per second. It's going horizontally. It's given in the question. Again, this was given in the question. The point was going to the left. So that acceleration is given to us. Uska component you can take along. Lekin don't assume that the point is going up with 6 meter per second square, so its component along the floor will be this much. That
No, you
concept
should
will be.
write that down. All you gave us was 2 arrows.
What?
Sir, you should write that down specifically. Like this thing is not rising up.
No, I didn't write it down, but I mentioned it like 5 times before I gave the question. So yeah, I'll try to write it down next time. Point noted. But next question I don't have to write because I'll do something else. Okay. So 15 more minutes. We'll have a break at 11. Okay. So I hope everything is understood in the previous question. Please let me know. Please let me know. Okay. If there is any doubt. Usually when you make arrows are the representation of vector quantities. So when in the question paper, you won't find them writing down the body is allowed only to move along the floor in words. They will just show they will tell you the direction of acceleration is indicated by the directions, and they will just make arrows. So yeah, I hope you understand. Do not make the same mistake. I think some people made this mistake again. Okay.
Okay.
Please do not make the mistake again. Okay. Now this next question is from a book called S.C. Verma. I think some of you might have heard. Okay. This guy is from IT Kanpur or Kharagpur. I think Kanpur. He's a physics professor. Wrote a very standard book that is used all over India. Very famous book. Very nice book. Very relevant book. But again, don't. There's a PDF version of it. Just test it out. If it's the book for you. Okay. Any kind
On
of
the
book.
first page, it says IIT Kanpur, retired professor, Department of Physics.
Yes, he also runs a YouTube channel where he clears doubts of students. It's a nice guy. I'm talking as if I met him. I didn't. But yeah. So this is essentially, let me start explaining from here only. So there is a ring, and there's a string passing through that ring that is tied on both ends onto the wall. So it's like a string is hanging tied between the walls, and there is a ring between them. So the ring can travel from left to right. Okay. So this ring at the bottom is attached to another string. Okay, and that string goes like this. String goes like this, and then there's a pulley here. There's a pulley here. Wait, let me make the pulley first.
So the ring is attached to the pulley.
The ring is attached to a string. That string is going over a pulley, and and the string comes down, and there's a block attached to this. Okay, this is the pulley.
Pulley is fixed. All springs are frictionless.
All pulleys are frictionless. Pulleys are frictionless. Strings are frictionless. Everything here is frictionless.
Sir,
Okay.
is the pulley fixed though?
Pulley is fixed. Whenever I make these slashed lines, it usually means it's a wall. Okay. So the notations of or diagrams you'll start understanding. Okay, as we go more and more into physics. These hashed lines here indicate that this is a wall which is fixed. Is relative motion with respect to everything in the system is 0. Okay. Like this is the ground frame of reference. Essentially, this is what it means. Okay. Now the question is this: if this block A here is moving downwards at 10 meter per second, okay, And this is the instance, this is the instant when this angle here is actually 53 degrees. Find out what is the velocity of the ring. What is the velocity of the ring? Okay, so if this block goes down, obviously you know the ring is going to move, right? So what is the velocity of ring? See, I'm writing it down. Velocity of ring. Question mark.
So in what direction is the ring moving, sir?
That I'm not going to tell. That's something that you have to decide. You have to find out. Because last few questions I gave you the direction and you were ignoring it. So this time I gave you a question where I don't need to tell you the direction. You have to figure it out on your own.
So the block is moving downwards though, right?
That is given. Okay. So block is moving down.
6 meters per second.
6 meters per second. Okay. That is not correct. But yeah, well, try more. Put your answers in the chat. I'll be back. Yes, 6 meters per second, 50 by 3, 12.5. How much is 12.5? 50 by 3 is the correct answer. 50 by 3 is the correct answer. Let us figure it out how. Okay. So, first thing is to identify where is the ring traveling. In which direction is this ring traveling? Okay.
Right. So is 50 by 3 correct answer?
Yes, 50 by 3 is the correct answer.
Okay, thank you.
Okay. So first thing I have to understand here is that the ring is going to travel in the horizontal direction like this. There is no exception to this. Why? Because the ring is on the string and the string is horizontal. So that means either the ring goes to the left or to the right. And I feel like it's going to the right because again, there's no physics in this. It's just common sense. If this thing goes down, the ring has to travel in this direction. So that is essentially the right hand side on the screen. Okay, so VR has to travel in this direction. So this is the original velocity of the ring. Okay, if the ring is traveling in that direction, what is its component along the string? What is its component along the string? Well, it's equals to VR cos 53.
Yes,
Are you with me?
Yes.
Yes. This is going to be VR cos 53. And perpendicular to this component will be what? VR sin 53.
Sin 53.
I do not care about this. I just need VR cos 53. Cos 53 is how much? 3 by 5?
Yes, sir.
Yes. So VR into 3 by 5 is the velocity of this point along the string. Along the string. And this should be equal to how much, guys?
10 meter per
This should be equal. Yes. VR into 3 by 5 should be equals to 10 meter per second.
So
So from
can you
here,
tell why is it equal to 10 meter per second?
Because string is moving
because
10 meter per second while the object is moving down to 10 meter per second. That's why.
yes, let me explain. Yes, if the block is moving down, then on this side the string is going down by 10. So from here also the string should also come with 10 only, no? That has been the discussion from the beginning. Okay, so along again, let me go back to that same statement. The components of velocity along the string is going to be same for both the bodies. The component of the velocity along the string is going to be same for both the bodies. It's going to be 10. It's going to be 10 because if the block goes down by 10, this end of the string is also going to go down by 10. Tell me if this makes sense.
Yes, sir.
Yes, sir.
So I had a doubt in for the VR sine. perpendicular downwards. It's not wrong, right? We're still getting the same answer.
Say what one more time?
So for the VR sine 53, on top you
Hmm.
drew the perpendicular upwards. If we drew it downwards, so it won't make a difference much, right?
You're saying something like this.
Yeah, sir, but like straight. Yeah, exactly. Pretty much.
Okay. Now tell me this. Like, if you go 3 meters in this direction, okay, and you go 4 meters in this direction, can you tell me where? Like, just a random question. Where do you end up? Like, which point? If you start from here, you go 3 meters in this direction, 4 meters in this direction. Do you go this way, right?
Yes, sir.
Okay. Now imagine I went 3 meters in this direction, okay, and 4 meters in this direction. Where do you think I end up? Like somewhere here.
Yes, sir.
Okay.
Oh, okay.
Are both these the same case?
Oh, okay, sir.
Okay. So yeah, you'll get the same answer. Why? Because we are not concerned about this particular component. We are not concerned about the perpendicular component. That's why you're getting the correct answer. But I hope you understood that the vectors, when you break a component of a vector, the vector should add up to become that vector. No, you're saying ki I'm going to break VR into two parts. Well, that those two parts when added back together should become VR. Uh, you cannot break it in directions where it is, not there.
Okay, sir. Thank you.
Okay. With that, ladies and gentlemen, let us take a small break. Okay. We'll meet again at 11:15. Really? You'll be that fast? I need to have breakfast. So, okay, we'll compromise. Let's meet at 11:10. Okay. And
Sir,
yeah.
if
Yes.
we have a doubt in the assignment that you had given, the assignment 2,
Yeah.
when can I ask you the doubt?
I know you are from ITPL, so just enjoy this break. And when we meet, I think we can just keep all your doubts together. Else, you can put it in the Mockstruck group, which you might have
Sir,
been.
like the solution was there, but I couldn't understand the solution.
Yeah, if that is the case, then you might have to wait till you meet me. Okay.
Okay.
If you didn't understand from the solution, for online students, what you can do is if you have doubts, you can request for a certain time in a week. Yeah, I'll give you a time. Okay, this time to this time I'll be clearing doubt session. So you can join that, and then you can ask your doubts. So it will be like a one-on-one session where I'll just clear your doubts. Okay, that's for the online students. But again, that's again subjectively. It's very difficult to arrange for the timings. Okay, so please inform me in the beginning, and I'll give you a time within the week, and we can sit and discuss all your doubts.
Okay, so I have to wait till the school opens.
Uh-huh. Ivan, I think we are going to meet anyway on 17, so all your doubts we
Okay.
can clear. Okay. So let's meet
Sir,
at 11. Yes.
sir, just out of curiosity, did you take painting in high school or something?
I did painting. Yes. Nice guess, dude. I did take painting in my 11th and 12th standard. So my school
No,
had
sir,
an
it's not a guess.
not
I
what?
saw you around campus and you were talking to NAFL kids, and I was like, are you the same person who I saw around campus? So,
Oh yeah, NAFL kids. Yes. I used to teach in Rajajinagar a year back. Cool, cool. I'll see you guys at 11:15. Have breakfast. Put something in your stomach. I will also. Okay. See you then. Guys, welcome back. Okay. So let us start our discussion. Let's continue our discussion. Okay. So this is all about fixed pulleys. Am I audible, guys? I hope I'm
Yes,
audible.
sir.
Okay. Okay. So the next topic I want to talk about is moving pulleys. Okay.
Sir, you just said this is all about fixed pulleys.
Now we are talking about moving pulleys. Yeah. Okay. So we had talked about what happens when the pulley is fixed. And we essentially started with the most basic case. If this thing goes up by X and the other side comes down by X, and then we extended to multiple problems and multiple scenarios. Uh, I think this class is relatively difficult. Okay, so there are two kinds of students who like. There's two way of responding to difficult classes. Okay, some people will just be like, "Ha, okay, I'm done with this," or let's figure it out later, or something like that. Now, there's another kind of kids who are like takes it as a challenge and they go, "Ki, ha, why is it difficult? Why is it difficult?" So I'll work my hardest and I'll make this difficult lecture easy. I'll do more problems. I'll probably rewatch the recording on parts where I was uncomfortable in, and then by the next time they come in, they will be like, "Ha, last lecture I understood and it was easy." Okay, but the other batch of kids will be like, "Sir, I didn't understand the last part, so the next lecture again goes." So I hope, and there will be both kinds of kids. I just hope the maximum number of kids are in the category where they take it as a challenge and they work uh, to make this hard lecture easy. You have decided to go for competitive exams and not just for school boards. You have already made the decision that your life is going to be hard from this point on. Okay, you're gonna have to work hard. You're gonna have to lose sleep. You're gonna have to constantly think about this one goal that you are after, one dream that you are after. Okay, so that's already a given. So I just hope ki you don't miss out on that bigger picture, ki what you are looking for. Okay, so I know this lecture is hard, but you need to. Yes, what is the doubt?
So you told that we could practice questions, but can you tell us from where can we practice questions? Because we haven't got the Centum modules or anything, and the new versions of books are yet to come, so I'm not able to get from where to practice.
Okay, so anyway, I'm gonna send out a assignment with solution like last time. You can practice from there.
Okay.
Practice
Sir,
from there.
send out bigger assignments. 6 questions, too little. Happens in half an hour. Very saddening.
This is still summer going on. I don't want to pressurize students. Okay, that's the idea of giving you just a small assignment. See, I love to give you 1,000 questions for practice, but it's just gonna demoralize you. Uh, as I complete the bridge course, after that the assignments are gonna be longer. But I have to think about not just one, but I have to think about everyone who is in this program. Okay. So right now, I don't want to scare people with 1,000 questions. But yes, and also you have to think about the content. That I have literally taught you like what, one or two classes, so I cannot give you assignment based on that. 1,000 questions will be just repetitive questions. That's just labor work, and tomorrow is Labor Day. So we don't want laborers. We need skillful workers and different types of questions where you're learning something out of the question. What's the point of doing like, I don't know, same type of question in five different times? It's not gonna make any much of a increase in your knowledge, right? So yeah, hence shorter assignments, good quality questions. Moving pulleys. In this situation, you have a pulley, and let's say there is a block on this end, there's a block on this end. So in the frame of reference of this pulley, okay, if I'm sitting on the pulley and watching, okay, if this thing goes up by X, guys, B goes down by X. This you have already agreed with. Okay. Now the question in moving pulleys is that what if the pulley itself goes up by a distance of Y? So what will be the net displacement of A? Guys, please type it in the chat. What will be the net displacement of A? The block has gone up by X with respect to the pulley, but the pulley has gone up by Y. So what is the displacement of A? It is, yes, it is X plus A. Why did someone say X minus A? I don't get it.
So it's Y.
Huh? Someone said X minus A. Okay. See, A is going up by X. The pulley is also going by Y. So that means the block will raise by a height of X plus Y. Why are you making a mistake here? Okay. What about displacement of B in the upward direction? So the X plus Y is in the upward direction, right? So I want to find out the displacement in the upward direction only. Okay. How much is the displacement of B in the upward direction, guys? Y minus X. Someone is saying Y minus X. Yes, Y minus X is correct. Okay. Now, some of you might be wondering, sir, what happens if X is greater? You don't have to worry. It's a vector quantity. The minus sign will indicate direction. So if your X is greater than Y, you'll get a negative number, right? So that negative number will automatically mean ki it is in the downward direction. So you don't have to worry. If you say Y minus X, you are absolutely correct. Okay. So I need to find a constraint relationship between SA and SB, displacement of A and displacement of B. Now, in fixed pulleys, it was very simple. SA was equal to SB. In this case, can I say SA equals to SB? Well, no, I cannot say. So I have to find something else. So what I'm going to do is I'm going to do SA plus SB. Tell me what is SA plus SB?
2Y.
It's 2 times Y. But what is Y? Y is what? What is Y?
The movement of the pulley.
Yes, the displacement of the pulley. Okay, so this gives rise to the constraint equation for a moving pulley, which is displacement of pulley is actually displacement of one of its ends plus the other end divided by 2. It's the average of displacement of the two ends of the pulley. That is the displacement of the pulley. Okay, now you know ki if this is the relationship of displacement, what will be the relationship on velocity, guys? Well, same
thing.
Velocity of pulley will be velocity of one end plus the velocity of the second end divided by 2. What will be acceleration of the pulley? What will be acceleration of the pulley?
Same
thing.
Same. Okay. With this in mind, and again, I showed you where this formula came up, but don't start, doing this kind of analysis in exams, okay, or in questions. If you are doubtful about a certain thing, yeah, go for it, but try to use the formulas here. Okay, now let me give you a easy question first. Easy question is in front of your screen right now. We have a pulley which is moving up with 10 meters per second. It is connected to two blocks. The block
number. Scroll up it for a second. For 1 second.
Did you miss something?
Yeah. Okay. Yes, so you can scroll up.
Okay. The left side block is going down by 5 meters per second, and this block B velocity is what you have to find out. Velocity of B is how much is what you are looking for. Okay. So
plus 10 meters per second. It's moving up by 15 meters per second. Sorry.
I don't want fast answer. I need well thought of accurate answers. Even if you're late, right now it's not the time to race. Okay, I'll tell you when you need.
Question.
So what should we find out?
Yeah, that's wait. If you miss out on any notes, please don't worry. I'm gonna share my notes after class. Okay, so if you miss out on anything, just leave a little bit of space, move on ahead. You have to find out the velocity of B. The pulley is going up by 10. Block A is coming down by 5. I need an accurate, slow answer. 15 is not the correct answer. Nice try though. Please, everyone else try. Yes, 25 is the correct answer. Okay. Karthik got it. Well, I am going to use the formula velocity of P is equal to velocity of A plus velocity of B by 2. Velocity of pulley is 10 meters per second. Velocity of A is
-5.
-5. It is -5. Why -5 though? Because in the derivation we took upward direction as positive. All the directions in the upward direction were taken positive. Okay, so upward direction I have taken positive plus VB we do not know, so divided by 2, this gives us VB as 25 meters per second. First question answered. Okay, if anybody has any doubt, please feel free to ask them.
Sir, I'm a bit confused, sir.
Yeah.
If the block A is going down by 5 meters per second, that means the block B is going upwards by 5 meters per second, right?
That would have been true if the pulley was fixed. The pulley was not moving.
Like if we consider the pulley as fixed, then it'd be moving up by 5 meters per second. And if we add the motion of the pulley, it become 15 meters per second, right? Because we have like S, we have the displacement of B plus displacement of pulley is the actual displacement of the block, right?
See, the thing is, this 5 meter per second is not the velocity with respect to the pulley. This 5 meter per second is actually the velocity you're seeing from the ground frame of reference. But with respect to this pulley, this thing is not moving down by 5 meter per second. I hope that makes sense. So
Yes,
when you
sir,
say
understood.
this end going down by 5 means this end comes up by 5, that statement is wrong. Is because 5 meter per second is not the velocity of this block with respect to the pulley. Does this make sense?
Yes, sir, understood.
Okay, no need to worry. Trust the formula. Okay, trust the formula. Follow the cult. Okay, let's move on ahead. Let's do one more question on this. If I give you like this, and this will challenge your intuition. Okay, up to now I'm just talking about the formula, but in this question I want to talk about you, whether you are able to understand the motion or not, because this is a relatively, or why am I making it fixed? This is not fixed. This is going up by 10 meter per second. Okay, this side of the string is fixed. This side of the string is fixed. This side, you know what, not meters, let's do displacement. You lift the pulley 10 meters. How much will the block attached on the other end lift? Come on, guys.
So 20 meters.
Someone says 20 meters.
So a quick question.
Wait.
How is the pulley moving when it's fixed from one end?
The pulley
The
is
string
moving,
is fixed
but the
from one
string
end.
is fixed.
The pulley is not fixed. The string is.
Yeah, the pulley is not fixed. It's only the string is fixed at one end. The pulley
Doesn't
can
make a
move up.
difference. It's like the same thing. Like
The
it's
pulley
String
can
will
move
move
one
along
end.
the pulley. The string is not attached to the pulley. It moves along the pulley. The pulley itself can move. The string is fixed on one end.
Okay. Okay, 1 second. 1 second, guys. Let me moving pulleys. Yes. I found it. Oops. Okay, let me put this here. Ivana, tell me if this brings any sense of intuition to your question. Does it slightly make more sense? I have one more picture.
Okay.
Does this sort of make an option? Like if you pull this string up right here, will the pulley not move? And see, this end of the pulley is fixed, right? And if you pull this string up, this pulley is going to move up. Yes.
Yeah.
Similarly, here also this side of the string is fixed,
Fixed.
but the pulley is not fixed. And if you pull this using your hand, this pulley is going to raise up. Yes.
Yeah.
Okay. No. Yes.
Yeah.
Are you
I
still-
got it.
are you
I
still
got
there?
it.
Okay. Let's see if I can copy a GIF. Oopsie daisy. Save image as GIF. Nope.
So isn't this a gym equipment?
Never mind. Yes. What?
Nothing, sir.
Okay. So yeah. I hope you understood. If you're not, I'm gonna send you another picture. This time on the group. Okay, I'll send it on the group. So it's a GIF. So its format will be supported only there. Here, if I bring it, it will become a still picture. And I don't want to change screens. It's a lot of work. So I'll send that GIF to the group, and you should notice key sometimes pulleys can also move. Okay. So if this thing is going up by 10 meters, according to the formula, yeah, the displacement of pulley is displacement of end A plus displacement of end B divided by 2. Well, displacement of pulley is 10 meters in the upward direction. Displacement of A would be how much? On this side will be displacement will be 0. Displacement on the other side will be 2. So from here, your displacement on the B side will be 20 meters. Thank you. Okay. Now, how do you understand this? Are you getting the intuition of why raising this 10 meters will raise this block by 20 meters?
Yes, sir.
How do you get that intuition? Well, you can make a reference line. Think of this like this. Like imagine ki this is the starting position. This is the starting position. Oh my God. Okay. This is the reference line. This is the reference line. If you raise the pulley by a height of, let's say, 10 meters, the center of the pulley rises by a height of 10 meters. Guys, tell me, how much string will be required on this side? Well, 10 meters. String. How much string will be required on this side? 10 meters. Where will that the total requirement of length to raise this pulley is 20 meters. Where will that 20 meters come from? Well, from this side of the pulley, the right side of the pulley has excess of string that goes up. So that means you're raising, by raising the pulley 10 meters, you have raised the block 20 meters. You have raised the block 20 meters. Okay. But this right here begs for another question, which is, sir, how did you magically reduce your work? Did you just design a machine that violated the conservation of energy of sorts because you just changed a 20-meter displacement into a 10-meter displacement? So if I were the guy, I'd raise the pulley only 10 meters and the block would have raised 20 meters. Is this magic? Is it violating the conservation of
the energy is done by the
No,
pulley,
sir.
right? So,
Yes.
Wait, one by one. I need you to answer one by one. Venkat, you can go ahead.
Sir, this is simple mechanics, right? Because the simple.
Yes. Now try it. What I'm asking you is very, very simple. Is it violating the conservation of energy principle? And if no, what is the price you are
So
paying?
could you repeat the question?
So you have
I
to use
didn't-
more energy to pull up the pulley.
No, that is not
so the
technically
pulley
correct.
is doing most of the work. That is why for pulling up the object, the pulley is doing most of the work.
Okay, that is also not correct. Sonak, would you like to try? Go ahead.
So I was the one who said it right now.
Oh, okay. Anyone else? Someone was asking what was the question. Aditya, yes.
So it would be
Sir,
because the
you're
one end is fixed
putting
to the
in-
ground. So can we say
Wait,
that one end is fixed to the ground?
Wait. Let Aditya speak. No, one by one I said. Aditya, yes, go ahead.
Sir, you're just putting in some amount of work. So, assuming the string is massless, the work required to lift the pulley, if the pulley is also massless, then no work for that. Just the work required to move block A by 20 meters. That's the work you're putting in, and it will gain some potential energy, mgh. That's equal to the work that you put in.
So are you saying ki because the pulley's mass is 0, so that means the force required to pull the pulley will also be 0?
No.
Because
No,
you said
add
work,
mass, then it would basically be moving two bodies, and then the pulley will gain
you will
some
still
potential
require
energy,
force. Yeah,
and
you will still require force.
and the block will gain some potential energy. Both of the potential energies gained added together will be equal to the amount of work you've done.
That is true. But is it a violation of conservation of energy because you just lifted the pulley by 10 meters and you by doing that you lifted the block by 20 meters? Okay, so that the question is revolving around that. It's nothing to do with potential.
Can we say that point A is also pulling the block B? The point on the ground is pulling the block. We can say that also, right?
You can, but again, there's a lot you're saying ki, this is extra information, but does not explain what my question is.
Sir, you're not pulling only the pulley, because to pull the pulley requires to lift up the blocks. So the work you're putting in is moving both objects. It's not like you're only doing this much work and that is just magically moving.
Okay. Cool. Anything else? Anyone else would like to contribute? The question is very, very simple. Okay. You are lifting a block by a distance of pulley by a distance of 10 meters, and somehow the block moved up by 20 meters. Is this a violation of conservation of energy? Because
you're not putting energy
exhaust-
into the pulley, you're putting energy into the string attached to the pulley, which is moving both the pulley and the block.
No, that is not a satisfactory explanation. Wait for it. I'm going to explain it, and you tell me whether that is a better explanation on how you guys are approaching this. Okay. If I want to talk about whether conservation of energy is violated or not, my first answer is no. That is what I want to hear. No, conservation of energy can never be violated. In classical mechanics, at least, conservation of energy is not violated. Okay, so energy is always conserved. So what is my question is, what is the price I'm paying for this half displacement reduction of, see, the answer lies in the fact that work done ka formula, I hope everyone knows the formula for work done. Work done is what? Force times displacement. So the thing is, the way you explain this is that yes, the displacement, it has become half, but the force has become twice. So you have to notice here that when you are raising and then all of this we'll study in Newton's laws of motion. Like for example, this is, let's say, mg force is acting on this, so that means the force on this string will also be mg. This string on this side will also have the same tension, because it's the same string, it will contain the same force. So the tension on the string will be equal to mg, and because this pulley is acted downwards by 2 times tension, the force, the net force required to pull this pulley will be twice if you had pulled the block. Okay, now since work done is defined as force into displacement, conservation of energy is not violated, because although you have decreased the displacement by half, your force has doubled. So and work done ka unit is joules, and net work done is change in kinetic energy and all that stuff you have studied in 9th 10th standard. If work done is same in both the cases, energy conservation is not violated. Okay, so I hope that made sense. If you have any doubt, feel free to ask.
Sir, how is the displacement cut in half? Because the displacement is doubled. The displacement of the block is doubled. Instead of 10
No,
meters.
I'm considering 2 cases. See, one, you lift the block 20 meters, and the other one is you lift the pulley 10 meters. So your displacement has half, but your force has doubled.
So the force basically we are exerting is, say, more than the so say we are exerting 40 newtons of force.
Yes.
The displacement we are doing is 20 meters for the block. Okay.
But if you like, for example, if let's say this is the 4 kg block, and you need 40 Newton force to raise this by a distance of, let's say, 20 meters. Okay, for a system which is attached to the pulley, and that pulley will require a force of 80 newtons to pull up, and you have to only displace 10 meters, and the block will automatically come up 20 meters.
Oh, so you're just saying that in both the cases work done is equal, so law of
in both the cases the work in both the cases work done is equal, but you have changed the proportions. In one case, force is high, displacement is low, and in one case, displacement is high and force is low. I'll give you one more example, and I'll take Aditya's doubt after that. There is this one case that you see in your everyday life. Okay, that is the jack. Do you know jack in cars? What is a jack?
The most powerful. No, that's the least powerful card in the, I think. Not
least powerful. No. It's a device that's given in
It's used to lift up the car. It used to lift the car up in order to change the tires.
So it's essentially a device like this that works under the same principle. Okay, if there's something like this, and I think you push this down, like you create small displacement, and this thing goes up. Okay, and it lifts the car. Now a car is what, close to 800 900 kgs. That's 9,000 newtons. And if your body weight is, I don't know, 60 kilos, I don't know, you should be able to lift max, I don't know, 60. If you're a normal person, 60 kilograms you should be able to lift. Okay, now that means you are able to apply only a force that is equals to 600 newton. How are you able to lift the car with 600 newtons? That's what, 9,000 newton. What you did is, see, you are creating lot of displacement. You're pushing this 10 times, 20 times, then this thing goes up like what, 1 inch up. Okay, so what you did is you're saying, I'm going to apply 600 newtons for so large displacement, so it can create a small amount of displacement against a 9,000 newton force. Okay, so that's a practical example where you are keeping the work done same, but somehow the force, you are disbalancing. So with a high displacement, low force, you are creating a high force with low displacement. Does that example make sense? Did that example make sense?
Yes,
So
sir.
can you explain like the similar question for like a double pulley system? How would that work also?
No, I'll go step by step. First single pulley systems, then I'll put double pulley systems. Okay, but yes,
So could you
double pulley
explain how the force is doubled? Like I understood how the displacement is half.
that force doubling, I think I'll teach you in Newton's laws of motion. Just little bit of patience I'm asking from you, because uh, a mom loves a baby. Okay, doesn't mean when he like as soon as the baby is born, we don't start feeding him chicken biryani just because the mother loves the baby. Just like that, as a teacher, I love you students, but I cannot start feeding you chicken biryani. You will just probably have diarrhea. Okay, so I need you. I am trying to feed you formula right now. Okay, so that you are physics babies right now. Okay, and if I start teaching you everything at once, all you do, you'll just get confused. So we'll go step by step, slowly. Just let me know whatever I'm teaching in and around that all those concepts are clear or not, because we have 2 years to study physics, and we'll go slow, and we'll take things at the appropriate time. Okay, so this is a nice question, really good question, but I think we'll have to wait for to answer that question. Why did the force become double? Right now you just have to take my word for it, it became double. Okay, uh, but later on when we go into Newton's laws of motion, which is pretty soon in 2 months time. Okay, oh my god, that's a long. Sir, I disagree. Energy is conserved because you lost energy. Yes, energy is conserved. Or did I say no? I accidentally said no. Energy is conserved in this situation, and energy
No,
is.
sir, you didn't say no. You said it is conserved because the work done on the block and the pulley is equal. That's not the reason.
What? No, I think.
Sir is comparing the work done on the block separately from the pulley, but the work done is the same on
Yeah,
each.
so
The displacement
energy
is
is
more on the
conserved.
block, but the displacement is less on the pulley, but more the force is more. The displacement is more on the block, but the force is less.
See, we can have a very constructive discussion on this, but I think we need to complete a little bit more, Aditya. Okay, so we'll take this up. I'm not saying we'll not take this up, but let the class finish by 12:30. Sit with me, sweet. Whoever is interested can sit with us for 10 more minutes, and we can discuss this. It's a very physics sometimes tends to become philosophical. So I have to draw the line where I need to cover the course versus engage in a very interesting discussion. So I will discuss this, but just give me a little bit of time to go further into this, and then let us continue. Okay, so like someone asked, I think someone asked me to do a double pulley system. You know what, I'm gonna do something better. Okay, let's do this. A pulley is going up by 10 meters per second. 10 meter per second. I'll do one better. I'll do you one better. Okay. That's the expression. So this pulley is connected to another pulley which is connected to two blocks. Okay, now this block is going up with 2 meters per second. Oh, 2 meters per second. However, the other block on the other side is coming down by 5 meters per second. Okay, this pulley on the right hand side is it is tied to another pulley which is which is tied to another two blocks. Okay, guys. So let's name this. Okay, A, B, C, and D. This D block right here is going up with 8 meters per second. What you have to find out is the velocity of C is how much. Okay, so let me repeat the question one more time. A pulley is connected to two pulleys. Those two pulleys, each of them are connected to two blocks A, B, C, D. A is going up 2 meter per second, B is coming down 5 meter per second, D is going up 8 meters per second. Find out what is the velocity of C. And all of these velocities are given in the reference frame of the ground.
So I was like disconnected for a second. So this is the question after the 20-meter question, right?
This is the question.
Okay.
Yes. Go ahead, find me VC.
So can velocity be negative? In this case?
Velocity negative means it just means ki downward direction.
So in this case, it can be negative, right?
Yeah. 35. Let's see if this is the correct answer. I'll be very happy if this is. Aditya, your numerical is correct, but it's not downward.
Sir, it's not downward? What?
It is not downward. According to my answer key, it is not.
Oh, okay. My bad. Wrong sign. I understood why. Never mind. I got 35 as the answer, but then I just assumed if one block is going up, the other must go down.
Why? Don't ever assume that. Don't you see here only see this is going up by 2, this is coming down by 5. So you already know whatever. So first thing you need to understand is that whatever you study for fixed pulleys is not going to hold for moving pulleys. You cannot say key displacement or velocity of A equal to velocity of B. If one thing goes up, it's not sure key the other thing comes up. Depends on the velocity of the pulley. It's the sign of your answer that will. Okay, so 3 people got the answer. I need everyone else to try, please. This is a very beautiful question. If you are able to do this, that means you understood constraint relationship. Well, you understood part of it. There's much more to learn in this. The questions can get overly complicated in this particular topic, because I think this is literally the most the topic where you need more of an IQ and critical thinking skills rather than practice. It's more to do with that. Yes, I'm very happy everybody got this. Okay, so if I use the formula, let's name this pulley E and this pulley as F. If I consider this to be one system, this is a moving pulley system, right? This is a moving pulley system where you know that E is connected to another pulley, so that means that E pulley is going to go with some velocity in the upward direction or downward direction, I don't know. So let's call this E velocity VE, and this end is going with 2 meters per second, and this end is going down with 5 meters per second. So if I use the formula, velocity of E would be 2 minus 5 by 2. Anybody has any issues, please let me know. What did I just do? Velocity of end A is 2 meters, velocity of end B is minus 5 because it's going down, divided by 2, making velocity of pulley E as minus 3 by 2 meter per second. Okay, now forget this one and consider this as the new system. This is the new system. In this new system, you have one pulley, okay, which is going up by 10 meter per second. This is connected to another end which is going down by 3 by 2 meter per second. How do I know this is going 3 by 2? We just found out. Okay, and there is this other side which is connected to obviously F that we need to find out. What is the velocity of that end F? Okay, Now you might be worried, sir, can we consider this to be a system because it is a pulley and pulley has another block attached to it? Well, it can have any amount of accessories it wants. But ultimately this pulley is connected to this pulley, right? So this can behave as a block here. It can behave as a block here. But the thing is, this block has other accessories attached to it, but it's not going to affect the overall formula here. So from here, can we guys can we find out VF, velocity of point F?
Yes, sir. It should be velocity VC
So,
plus 8 meter per second by 2.
So we'll again use this formula. Velocity of pulley is the velocity of end A plus velocity of end B by 2. So velocity of pulley is 10. Velocity of A is minus 3 by 2. Velocity of B is, well, I don't know. VF we'll put, okay, and divided by 2. From here, VF, the velocity of the pulley F, comes out to be, I think, 20 plus 3 by 2.
Yes, sir.
Okay, this comes out to be 20 plus 3 by 2. Now what do I do, guys? What do I do next?
So you can find VF and then equate it.
VF, you take VF.
Okay, so let me move this up slightly. I think I can move this up a bit further. Okay. Yes. Now, if I consider this to be one system, see, I'm going to show you. Consider this to be one system right here. Consider this to be one system. For this system, I can say the velocity of F is equals to velocity of C plus velocity of D by 2. Again, the same formula I'm using. Velocity of pulley is velocity of end A plus velocity of end B by 2. Okay. So velocity of F, we know it's 20 plus 3 by 2. Okay. Velocity of C is something we need to find out. How much should I put velocity of D? Well, 8. 8 is given to us, divided by 2. So when you do this, you get velocity of C as 43 minus 8. Nice. Okay. So that is how you do this problem. If you have any doubt, feel free to ask. Feel free to ask.
So how does it move upwards though? It's because it's plus, that's all.
That's all. Now, if you're again facing difficulty with the intuition, let me ask you this. Okay, if let me ask you in terms of with respect to the pulley. Let's say this thing went up by 2 meters. Okay. So with respect to the pulley, this thing will come down by 2 meters. Yes or no?
Yes, sir.
With respect to the pulley. Now imagine this thing went up by 10 meters. What will be the displacement of this block, lady who asked that out? This will be 10 plus 12, so 12 meters. What will be the displacement of this block? Although this block came down, it was supposed to come down, but the pulley's displacement is so high up, this will be 10 minus 2, 8 meters in the upward direction. Do you understand? So when you are working with a moving pulleys, don't think if this side goes up, the other side comes down. Okay, so both the sides can go up. This side went up by 12 meters. This side only went up by 8 meters. Does this clear your doubt?
Yes, sir. Yes.
Okay, so something similar is happening here. So don't get worried because this thing is 8 going up. How is this still going up with 35 meter per second? How is that possible? Well, it is possible because the pulley is not static. You cannot apply SA equal to SB for moving pulleys. Okay, let's do one more and then we'll talk about something called the wedge constraints. Wedge constraints. Okay. Okay. Now, what kind of question should I give? Yes, this one. Yeah. Okay. So
Sir, why so many with pulleys? Give one with a spring or something. Not change it a little.
I have not taught spring right now. Why do you want springs? Have you by chance studied with Centum before?
Barely.
Okay. Who was your teacher? Ankur sir?
Rohit sir.
Okay.
That was only for one class. I don't know why.
So I think that's why, like, you are from foundation, right? So you know stuff, but you should not get impatient. Okay. I've seen your seniors. There are students who are like, who have done foundation. Sometimes it works against them. Be careful. So I hope you are able to understand the setup here. Okay. It's a very beautiful setup. I know some people are not enjoying this, but some of you are probably enjoying this. Like, see, the beauty of physics is not in doing repetitive questions like in math. Math, you understand a particular topic and it just go on, you know, doing the same type of stuff. I'm not dissing math here. It's just truth. Okay. But it's like you learn a formula and just keep doing. And the more you practice, the better you get at it. Okay. But in physics, it's more applied math. So I'm not saying physics is something different. It's a part of math only. We're using doing math only. But here we are essentially, how can I say, most of the time we are, you know, discovering something new with every step that we are doing. Okay. So let's say VB goes down, the B block is going down with velocity VB. This is given in the question. Okay. VB is given in the question. Your job is to find out what will be the velocity of A. How much will be this velocity in terms of VB, that is.
So all the three, the 1.6, all the three pulleys is connected to B.
So this is, let's name these. Let's call them pulley number 1, pulley number 2, pulley number 3. Okay. So pulley 1 is attached to the ceiling and the rope is connected to B and goes over and connected to pulley B, pulley 2. Pulley 2, one end is connected to block B and the other goes to connect to pulley 3. And pulley 3 is one end is connected to block B and it goes over to connect to block A. Okay. Very beautiful question. Very beautiful question. Okay. Find out the velocity of A in terms of B. Yes, Aditya. You want springs?
Or I don't know, sponges or something different.
Anybody got the answer? Please let me know.
Sir, is
Two
it
more.
3BB?
3 times. I don't know. I don't think that is the answer. 3 is not the correct answer, but well tried. Let's try more. Try to figure out where you made a mistake.
So you need to find the velocity of A in terms of velocity of B, right?
Yeah. Like, is VA equal to VB? Well, the answer is no. Why is there a minus sign, Aditya? Minus sign would mean ki.
So can we name the first pulley as some letters so we know what to multiply with?
Huh?
Sir, I'm wrong.
Sir, is it
Wait.
7?
One after the other. I think someone was asking it out. Let me answer that and one by one. Yes.
So could we name them as letters? Because I did it in a different method. So could we name like the first, second, and third pulley as letters, and then we could multiply them?
You can name whatever. You name them as your best friends. It's the answer should come correct. You can name whatever you want. Yes, the other person. Aditya, what were you saying?
So I'm wrong?
Numerically, you are correct, but I have already designated correct directions. Okay, if VB goes down, VA comes up. So you should not put a minus sign.
Okay,
If you put
fine.
a minus
7
sign,
VB, sir. Minus
huh?
minus is plus, sir.
Okay. Yes. So 7 BB is correct.
Sir, you asked to find VA, not what minus VA is.
Okay. That we will discuss when we go into vector quantities. Like
If it's VA, then it should be negative VB, no?
No, Aditya, you will understand what I'm saying here. Wait. I cannot just say yes just to make you happy. This has to be technically correct. See, if I say I want to go in this direction 10 meters, that is absolutely correct. Okay. If I want to say I want to go to left 10 meters, this is absolutely correct. Okay. But if I say that I'm going in this direction minus 10 meters, what does it actually mean? It means that I'm not going to
Opposite by
right.
10 meters.
I'm going to the left 10 meters, right? So a minus sign in physics represents direction. So as I have shown the correct direction of VA and VB, your numerical answer is absolutely correct. But if you say VA is equals to minus 7 times VB, and these are vector quantities, this would mean that if VA was going up, then VB will also be going up, because VB I have shown in the downward direction, right? VB is a downward direction, so minus 7 times VB would be in the upward direction. Now you tell me whether this is technically correct or not. See, again, your answer is numerically correct, okay? But minus 7 VB would represent what? That you have to think. Okay.
So I'm not able to get her to solve this.
Huh?
I'm not able to solve this. Can you help?
Yes, I'm gonna
So even
help
I
this.
got minus 7, baby.
Okay, let's see. See, first of all, the first pulley number 1 is really easy, because it's a fixed pulley and we are comfortable with fixed pulley. Why? Because if I tell you this end which is connected to B is going down with VB, can you tell me what is the velocity of this point 2?
It's going up by VB.
It's a fixed pulley.
If
it's a fixed pulley on this end is going down with VB, then this end will definitely come up by VB. That is the basic logic for a fixed pulley. Fixed pulley, you don't have to worry. So when I'm analyzing pulley one, all I have to do is this end going down by VB means this end comes up by VB. So this gives me the velocity of pulley 2. So when I'm analyzing pulley 2 is going up by VB. Do you agree with this? We just found out.
So like overall, right? The pulley.
So these
is
are fixed pulleys, so.
Because pulley 1 is connected to pulley 2, this end is going up by VB. That means pulley number 2 is going up with VB. Okay. Now this end of this pulley is going down by VB. How many of you understood this or didn't understand this? Because pulley 2 is connected to B block, so the B block was going downwards with VB. So that means this end of the pulley is going downwards with VB. Pulley B itself is going upwards with VB, but this end of the pulley is going downwards by VB. How many of you did not understand? Feel free to ask.
So what pulley are you talking about?
I didn't understand your doubt. Can you repeat?
So which pulley are you talking about, sir? Which one is going down by VB? Like the first pulley?
Pulley number 2. Pulley number 2's left end. I'm considering this pulley right here. Do you see this? No. Pulley number 2, center of this pulley is going up by VB. The left end, which is connected to block B, is going downwards with VB, no? And this thing is connected to pulley number 3. This is pulley number 3.
So we can use that formula, right? The
Yes, we can use that formula. Shristi, talk to me. If
Yes,
you're not
sir.
able to understand, feel free to ask.
No, sir, I understood, sir. I did it. I saw it in a different way, so I was wondering.
Okay. So if I'm using the pulley formula here, so I will say ki the velocity of the pulley, which is how much VB, is equals to velocity
minus
of end
VB plus
minus VB. Very nice, because the left end is going downwards with VB,
plus velocity
plus
of pulley 3.
velocity of pulley 3 divided by 2. So from here, I get the velocity of the third pulley, which is how
Which is
much?
3 VB.
Everyone is clear with this or not?
Yes,
Please
sir.
let me know. Srishti?
Yes, sir.
Okay, cool. Now let's talk about pulley number 3. What is the velocity of pulley number 3? Array, we just found out, no?
3 VB.
3
It is
VB.
it is going up with 3 times of VB. What is happening to the left end of this pulley?
It's going up. Oh,
It's
wait,
going
left
down by
down
VB.
by VB. Yeah.
Down
It's
by
going
VB.
down by VB. Why? Because again, pulley number 3 is connected to on the left hand to this block B. So this end is going down by VB, and this end is connected to VA, and VA is acting upwards. This is how I show VA. Are you with me?
Yes,
Okay.
sir.
So again, I'm going to write the equation velocity of pulley, which is 3 times of VB, is equals to velocity of end A, which is how much, guys?
VA.
Minus VB. Okay. Plus VA divided by 2. Everybody agrees with this?
Yes, sir.
Minus VB on the left hand side, right hand side, VA going up divided by 2. So from here, 7 times of VB will be equal to VA. Okay. A lot of you got positive answer, 7 VB. I'm happy. Okay. Please let me know if there is any doubt.
So can we solve this in a different way? Like we can add as we go up, like from third pulley we add and then we go to the second pulley.
That way also you can go. You can start with VA, okay, and we find out what is the velocity of this pulley number 3, okay, and then you go pulley number 2, and then you go pulley number 1. But in pulley number 1, understand key pulley number 1 is a fixed pulley. So whatever you get velocity of pulley number 2 will be equal to VB. Okay. And also notice the directions are correct. So that means you need not put a minus sign. The minus sign is
Oh, so what I did was after doing 3 in second, and as I went up, I just equated to 0, and then I got the answer as 7 VB.
Okay.
For the last pulley.
So okay, yes, Sonak ask.
Nothing, sir.
Okay. Okay, the last part of today's lecture is going to be wedge constraints. Okay, it's going to be wedge constraints.
The random question: did you just see flying emojis?
I did.
Cool, that works. Okay.
Wedge constraints. Okay. Now, what on earth is wedge constraints? Well, in the previous question, we had discussed about the constraint being the length of the wire. Okay, the length of the wire was the ultimate constraint. In this kind of constraint, the bodies themselves will be constraints. Okay, so usually two conditions are assumed to be true whenever we are doing wedge constraints, unless something is specified. These are the common conditions that we work with. The first condition is that whenever we are doing constraint problems which involves two bodies, and let me make these two bodies here, A and B. The first thing is that in the question it is mentioned that the contact between A and B is usually not lost, Okay, the contact between A and B is not lost. So if you're doing a wedge constraint problem, you can essentially apply the theory that I'm going to teach now. If you understand the contact between A and B are not going to be lost, it is not going to be lost. Okay. Second
So
thing that
what
you're
do you
looking.
mean that contact between A and B?
We'll talk about it. Give me a little bit time. I'll explain. Second thing is that bodies are rigid. Bodies are rigid. Okay. And essentially integrity of these bodies are maintained. Integrity of these bodies are maintained. Okay, now what does these 2 points mean? Now let me give you an example and you will be able to understand. Okay, so let's say this is block A and it is in contact with block B. Okay, let me ask you this: if this thing starts moving with 2 meter per second, what will be the velocity of B? If
2
velocity
meter
of
per
A,
second.
2 meter per second.
why?
So because because A is applying since the velocity of 2 meter per second is for A, the A is also applying the same amount of velocity to B, because of which the B is moving 2 meter
A
per
transfer of velocity is happening.
second.
So because both objects are in contact, sir.
That is the correct answer. You can never transfer velocity. What is this transfer of velocity we
Sir,
are
I have
talking
a doubt.
about? Huh?
Sir, now B will have more mass, no, sir, than A. So shouldn't
Yeah,
it?
I don't know why, but in every batch I had this question. He said, "Is this velocity has something to do with the mass?" It does not. Constraint relationships are independent of mass, and I'm going to show you why. Okay, constraint relationship has only to do with whether the contact has to be maintained or not. If there is contact to be maintained, the block behind moving at 20 meter per second or anyone, it's again, we are not talking about the cause. If I say ki B is moving with 2 meters per second, it's moving with 2 meters per second, and I say ki contact is not lost between A and B, then A should also move by 2 meter per second. Okay, when A moves with 2 meter per second, it's not that A is applying a velocity of 2 meter per second on B. It is not true. It is because of this particular constraint relationship that between A and B constraint, because if this is moving at 2 meter per second and this is only moving at 1 meter per second, what will happen?
They
Contact will
won't
be
be
lost.
in
Contact is lost.
touching each other anymore.
The contact between B and A will be lost because B is moving faster, A is moving slower. The separation between them is going to increase. The contact between them is going to get lost. Tell me if this makes sense.
Yes, sir.
Okay, so what
So
if
they
this?
should not get separated. That's the condition, right?
What
They both
what
should remain together.
They should not get what stuck.
They should not get separated, right? They should remain together.
The contact between A and B is not lost. Okay, what if A starts traveling with 3 meters per second?
So velocity of B will increase.
B will be 3.
No. What if B is 2 and A is 3?
So
So
then
A will apply some kind of force on B because they're rigid, right? And the integrity are maintained. A can't just go past B.
Okay, the integrity of block B will be lost, or block A will be lost, because we know that they are not stretchable. These are rigid bodies. So if I'm saying that the back body is going with 3 meters per second, it's essentially going into block B because they cannot come any closer. They'll just break each other. That's very philosophical. Okay, so I hope you understood that the contact between these are the two conditions I showed you right now are going to govern the motion of rigid bodies and wedge constraints. Okay, this is the fundamental principle of the wedge constraints. Okay,
So can you
now
explain the second one? Okay, the second condition.
the second condition I just explained. No, if this thing starts going with 3 meters per second, okay, if this block starts, let me undo and let's see if I can. If this thing starts going with 3 meters per second velocity, it's going to break B, right? So that means if I say that bodies are rigid, that means the back the velocity is it cannot be 3 meter per second, because if the block A is traveling at 3 meter per second, it's going to break into B, or it's going to smush B. Okay, if that makes sense. Okay,
Yeah.
Aditya asked.
Sir, what do you mean when you say the integrity of an object?
It's just it's a fancy word of saying it remains intact. It does not break. It is rigid. It is not stretchable. It is not like a sponge. It's a rigid body. I don't know how to explain.
Iron block.
Okay, I got it.
Yes, iron block. Treat it like iron block, because we are talking about theory. So in theory, we start out with easy assumptions key the body's integrity is not is maintained, sorry. Okay, now when you do this again, the same concept applies. Okay, is it only the horizontal velocity are we concerned about, or something to do with the tangential velocities as well? Well, this is where you have to write a note. See, if the blocks are moving in the tangential direction, at that instant, it is not, it is irrelevant to us ki, it will still maintain contact, and it's not going to undermine the integrity of these blocks. Okay, so tangential velocities have nothing to do with constraint relationship, just like in strings the perpendicular direction components did not make any difference, right? Here also it's not gonna make any difference. I hope that makes sense. Okay, it's only the okay, so what you need to write down one statement is that along the common normal, now what is common normal, I'm going to explain. Okay, along the common normal, components of velocity should remain same. Okay, now let me ask you this. Let's say this is block A. Okay, this is block B, and they're not kept on the ground, they are kept on the table, and I'm looking from top. This is the top view. Okay, and the dotted line is the forward direction. Let's say velocity of block A is in this direction. Okay, and it is making an angle of 60 degrees with the forward direction. Okay, again remember, this is not on the ground, this is on a table, I'm looking from top. Okay, and let's say block B is traveling in this direction at an angle of 30 degrees. Okay, 30 degrees, and let's say this is I don't know, 10 meter per second. Find out velocity VB, guys. I think this you might be able to do. Please note the new timings of class. It ends at 12:30. Last time I accidentally put a reminder for 12 o'clock, so I had to leave at 12 o'clock. But classes will usually run up to 12:30. Ten by root 3. Okay, let's see. Let's see if this is correct. Well, first of all, what is common normal? Well, imagine something is in contact with another object. Then this is the contact surface. This is the contact surface, and normal means perpendicular to that normal surface. So this is the normal. This is the common normal. Okay, this is the common normal. In this case, the contact between block A and block B. So if this is block A, this is block B. This was the common normal. This was the common normal. Oh, sorry. This was the common contact surface. Sorry, not that. I'm using the wrong words. Okay, I'm using the wrong words. So this is the contact surface, and perpendicular to this is this direction. Okay, so along this direction, the velocity needs to be same. It's not that the velocity A should be equal to velocity B is not the ultimate statement. The statement is that velocity along these directions should be same. So if this is 60 degree, the component of this velocity along the normal is how much? 10 cos 60.
Cos 60.
Okay, Similarly, block B, if it is going like this, VB, and this angle here being 30 degree, how much will be this component along the common normal? VB cos.
Cos 30.
So you'll have to say, sir, 10 cos 60 should be equal to VB cos 30. You cannot say VA equal to VB. That is not true. That is only true for the most basic case where both of them are traveling in the same direction. Okay. But if you have situations like this is what you have to follow. Along the common normal, find out the components of velocity and then make them same. Make them same. Okay. So 10 cos 60 is what? 5. And VB cos 30 is root 3 by 2. So yeah, VB is what? 10 by root 3. This is absolutely correct, Mundo. Okay. Okay. 10 by root 3 is the correct answer. If you have any doubt, feel free to ask. Okay. So how do you, so if there is an algorithm to like 4 steps to finding out these constraint relationship in wedge systems. So first you need to just identify, I'm just noting down all the steps that I did in the previous question. Identify the common surface. Identify the common surface. Okay. Step number 2 is draw the normal to this surface. Draw the normal to this surface. Okay. What did I do next? Well, I took components of either displacement, velocity, or acceleration. Okay, along this normal. Okay, and the last step, what is the last step? The last step is to equate these components. Equate these components. So what are the 4 steps I followed during this question? Well, I first identified the contact surface. Then I drew the normal to this surface. Then I found out components along these normal direction. And then at the end, I just equated the 2 components and then said, yeah, this is correct. Now this can happen for all displacement velocities and acceleration concepts. Okay. Here, when you're drawing the normal to a surface, well, if it's a plane surface, it's really easy to make the normal. But how do you make a normal for a curved surface? Do you know? How do you make normal?
At that particular point, we draw a line and then draw a line perpendicular.
But are you saying I'll make it from the tangent and then I'll make a normal to that? Well, that is too time taking. You just join to the radius.
Okay.
Okay. A line joining, so not the radius, the center of the circle. Okay. Center of the circle is always perpendicular or it's always normal to that particular surface. Okay. So the line joining, essentially radius is always perpendicular to tangent. This property you might have already learned. Okay, so if you have a curvature and you know the center of the curvature, just draw a line from the center of curvature to that point and you will have your normal. Normal in case of curvatures are the line joining from the center. That's what I wanted to say. Last question for today's class. Based on wedge constraints.
Sir, I have one doubt, sir.
Yes.
So what the previous question, sir, would it be VB cos theta or sin theta, sir? I'm confused.
Which one?
I think we always take cos theta and not sin theta.
What is your doubt? Can you repeat?
It's a VB would be sin 30, right?
No, VB has 2 components. You're correct.
VB sin 30, like 10 cos 60 should be VB sin 30, right? Not cos 30.
No, see, towards theta, this angle right here is 30 degrees. So towards theta is cos 30. Away from theta in this direction would be VB sin 30. But we don't need sin 30 because it's the perpendicular component. It's not going to be useful. Only the component of velocity along the common normal is going to help or going to put a constraint on the motion, not the perpendicular one. Does that clear your doubt?
Yes, sir, I understood.
Okay.
Sir, what about for the block A then?
One by one.
So what about for block A?
For block A also, this is one component 10 cos 60. One component will be like this 10 sin 60, but again, this is not relevant to us. So we take 10 cos 60. Towards theta, cos theta, away from theta, sin theta. Yes.
So why is it called wedge constraint? There are no wedges.
I know.
Where my doubt exactly.
So why is it called wedge constants? Well, let me make a wedge. Well, I think this topic is known as wedge constraint because most of the time the application is done on wedges. Okay. So what is a wedge? It's essentially a triangular setup. Okay. Where you can imagine this like in 3D, it will look like this. Okay. This is like a ramp. Uh, so on the side, it looks like this. So it's a right triangle like this. But if you keep a block on top of it, the block will essentially slide. Okay, slide down. But if we don't make this kind of complicated structures, on here we just showed a side view like this. In side view, this thing rolling down would just look like this. Okay, I hope you understood what a wedge is. This is known as a wedge. This is known as a wedge. Okay. Now we are only going to show the side view, and this angle right here is known as the wedge angle. This theta right here is known as the wedge angle. Okay. Now I'm going to give you a question, and this is the last question for today's class. If
so could you scroll up 1 second? I'm so sorry.
I told you, don't get worried if you miss something.
Yes, sir. Thank you.
Okay. So here the question is something like this. I have a wedge whose wedge angle is 37 degrees. 37 degrees wedge angle. On top of it is a block which is sliding down. A block. Okay, I'm gonna have my OCD kick in right here. Yes, very nice. So I have a block. This block is A. The wedge. Oh my God. This wedge here is B. Okay. Now when I see what happens is that all the surfaces are frictionless. That means there is no friction between the wedge and the floor also. Okay. So can you tell me what is the tendency of wedge to, in what direction is the wedge moving? If I let go of everything here that is drawn in the diagram here, if I let go of everything here, where will block be, or where will the wedge go?
In the left direction.
Yes,
Right.
in the left direction. Okay. So let's assign that velocity VB. Okay.
So why will it go in the left section?
Huh?
Why will it go in the left
It's
direction?
kept on the floor. It can either go to the right or left. You decide. You tell me in which direction should it go. Well, it is on the floor, so it cannot fly up or down.
Yeah, so it should
It
be
can
left or right, right? So how do you know that it will be left?
Because the wedge angle is on the right.
No, it's like you have to get this intuition. I don't think I can explain the physics, but it's mostly like if this thing is coming down, definitely this will try to go to left. I think
If block
You
is
can do
moving downward, it's
conservation
also
of
going to
energy
fly
perspective.
downward first on the block B.
you can explain it in terms of force. Well,
Okay,
again,
yeah, I got it now.
it's like A will apply downward force, but the normal will be at an angle like this. Okay.
Yeah.
So that means this block will also apply a force in this direction, which will have a component in this direction. See, that's why I'm saying, like, let me the exact force analysis for this will be done in Newton's laws of motion. There's no point me giving you that explanation right now. But right now, I think this should be intuition based. Okay, if that thing is sliding down, tendency of the block B, there's no way this thing will go on this side, right? Because A is sliding down in this direction, so obviously B will try to escape the other way. Okay, maybe practically I can show you when we meet in school. I will bring a wedge with me.
Yeah, I got it now.
Okay, so guys, listen to this. A will have a velocity in this direction with respect to the wedge. With respect to the wedge, the block A is sliding down in this direction. But you have to also understand, it's like what I'm saying is, for example, you have a lift. Okay, the lift is going up, and you are traveling in this direction. What is the net direction of your velocity? Well, you have a velocity in this direction, you have a velocity in the upward direction, so net velocity is like this, right? Okay.
Yes, sir.
So here also something like that is happening. Wedge A has a velocity in this direction with respect to the wedge. but the wedge also is moving to the left, right? So it will be an addition of both, and the end result for that is this. When I look from the ground, I see wedge A coming down, perfectly coming down. Why? Because it's a vector addition of two vector quantities. One is like it's sliding in this direction, but it is also going in this direction. Why? Because the whole wedge is moving in that direction. So the vector addition of both has yielded a result, and this is only like in this particular scenario, that when I see from the ground, I see that block A is actually moving 5 meters per second in the downward direction. The question is, how much is VB? I hope you understood the question. Block B or wedge B is moving to the left. Okay, it's given in the question. Block A is moving downwards with 5 meters per second. That is again given in the question. Okay. Although it should be understood by intuition, but also it will, like in the question, they have told us that VB is going in this direction. Okay. All you have to do is find out what is the value of VB. Last question, guys. I think you can do this. Is it 4? Let's check. Okay. What is the direction of common contact? Well, this is the direction of common contact. Do you see that this is how the common contact would look like?
Yes, sir.
Everyone is comfortable that this is the inclination of the common surface, okay, or the contact surface, common surface or the contact surface. The perpendicular to that would be something like this. Yes or no, everybody?
Yes, sir.
Okay. Now the velocity of block A is actually like downwards. It's downwards. So I'm gonna make it like this. This is velocity of A. Can someone tell me how much is this angle?
37
degrees.
37.
Yes. So we know that this is 37. So this is 53. So definitely this is 37. I hope everybody understood this.
Yes.
Okay. What about block B? Block B is moving in this direction. Can someone tell me how much is this angle right here?
53.
53. Very nice. Because if this is 37, this is 37, this is 90 degrees, so this is 53. Very nice. Okay. So along the common normal, the velocity should be same. So what is the component of VA along the common normal? Please tell me.
VA cos 37.
Very nice. What is the component of VB along the common normal?
Sine 53.
VB?
Sine 53.
Why do you do this?
Cos 53.
Every time you're making a mistake. See.
Cos 53.
Ha. Towards theta, no? This is VB. This angle right here is 53. So towards theta will be what? Cos 53. Away from theta would be sine 53. What is the doubt? I think this is because you didn't revise previous class.
Sir, I was absent in previous class. I didn't get to see the recording yet.
You have to watch the recording. Did I not share the recording?
I don't think so.
I think I shared the previous class recordings, right? So
I'm not sure. I need to check.
I did. I think I did. Cos 37 is how much? 4 by 5?
Sir, so is VB equal to VA, sir? Because cos 37 should be equal to sine 53.
No, I think I wrote mistake. This is cos 53. I think you told me the wrong answer somehow.
So VB is 20 by 3, right?
Huh?
It should be 20 by 3.
Yes. So 5 cancels. VB is 20 by 3. Okay. Again, if you are facing difficulty with taking components, please visit the previous video. Okay. If this angle right here is 53, then the component of VB along the normal will be cos 53. Okay. It is not sine 53. That's why I said in the beginning of the class. Okay. If you're
So
not
how
revising,
if you take the angle along the normal and not along the common surface, right?
say what?
We have to take the angle along the normal and not the common surface, right?
No, you can take angles anywhere. You'll get the same thing. Like for example, if you take this angle as 37, now you can see the component of this green vector along the normal will be what?
It
Away
will be
from theta
sine
is
53.
sine. So you will say VB sine 37, which
Yeah.
is again what? VB into 3 by
3 by
5,
5.
which is exactly the same. So you take whichever angle you want, but always remember if you have a vector towards the theta, that component will be VB cos theta, away from theta will be VB sine theta. Tell me if this makes sense.
Yes, sir.
So
Okay.
it won't be cos 0 degrees, it'll be cos 53 degrees when you're doing it for VB.
Again, your voice is very low. I cannot hear. I can barely hear what you're saying. Shrishti, please speak up slightly more.
So it won't be 0 degrees, it'll be 53 degrees for cos VB cos 53. Because I took it as 0 degrees, that's why I got 4.
Oh, I see. So yeah, don't make silly errors, I guess. Okay, look for the angles properly. With that, I'd like to conclude today's class. Recordings will be available. I'll be sending one assignment. Okay, you can submit this assignment to my email till you get your class full logins. No need to worry.
Yes, sir.
Okay, and I'll stay back for that fancy discussion if anyone wants to stay back for that. Okay. So please let me know if you have any doubt in this question. Otherwise, thank you for being here. I'll see you next class.
So next class is after 1 week's break, right? Because there's a holiday, if I'm not wrong.
Yeah, that I will announce in the group. I don't know yet, but I think next week is
100th is holiday. 100th is holiday.
Centum holidays start from May 1st to May 10th. So next class maybe after 10th.
So also do we have to attend classes after the school starts?
Huh?
Like after we start going to ITPL, do we still have to attend the online class?
No, you don't.
It will be offline only, right?
In ITPL everything is offline.
Okay.
Okay. Now back to the fancy philosophical question. Where did it go?
Sir, after May 10, will we still have classes?
Yes, one more class we'll have for calculus. I need to teach you a little bit of calculus before we go in.
So like the basics only, right? Or the calculus.
Yes, basics of calculus. How much ever is required for physics, that much I'll teach.
Okay, sir.
Yes, Aditya, if you're here, tell me what was your point in this particular question. I just will be very sad if you left.
So he's here.
Oh, he's here. Aditya, Helen, let me know. You're muted. Okay. Is anyone else there who wants to debate on this or tell me their point of view on this?
So what was the debate again on this?
So Aditya said that energy is conserved because you lose energy doing the work.
The thing was, my question was this. See, if I want to lift a block, I want to lift a block by, let's say, 20 meters. And then compare that to a situation when I'm using a machine, a simple machine of a pulley, okay, and I'm raising only 10 meters. The end product of both these systems is essentially the same, right? This is raising 20 meters. This is also raising 20 meters, okay? But the concept was this: if I raise the block 20 meters by hand, am I doing more work compared to when I'm lifting using a pulley? And if that's so, there's a violation of conservation of energy. Then I can
with pulley, right? Because for pulley also we have to exert some more force because pulley has mass.
Yes, exactly. Yes, exactly. This was my
And then if
explanation.
we are concerned that the pulley is massless, till then we have to apply some amount of force to lift the pulley along with the block. So more work is being done.
So I think yes, his point was essentially revolving around the fact he said work done will be not on pulley but pulley and block combined or something like that. But I was not talking about this one system. I was
So
talking
like
about
what he said was like the work has nothing to do with the amount with the conservation of energy. That's what he said.
oh no, that is wrong then. If he said that, that is wrong because what there is something called work energy theorem, which says ki the work done by all the forces is change in kinetic energy. So whatever work done we do determines what kind of energy change happens in that body. So they are connected, very much connected.
Sir, I just said the total work done is compensated by potential energy, and it doesn't really matter if the work done on the pulley and the block are the same.
Okay. So again, I think what the confusion, Aditya, is about the fact that I'm talking about two systems here, not a single system. I did not say that the work done here is only because of the pulley or only because of the block. I was talking about the scenario ki if I have to lift the block with my hand 20 meters versus this system where I'm using a pulley, does does it mean am I using less amount of work in this? Is there is the work same in both cases or the work greater in this case, Aditya, right? So
Understood, sir.
huh
Understood, sir.
okay, so this was the discussion. So I was saying if you lift a block by 20 meters, yes, you have double the displacement, but you're lifting it with half the force, double the displacement. Okay, but here yeah, that was the discussion going on. Okay. So I hope you understood. Work done in both the cases will be equal because there is no, conservation of energy is not getting violated in this. Okay. So I hope you understood. Please let me know if there are any other doubts. I will leave you to it. Okay. And I will see you after vacation. Till then, take
Okay.
care. Keep enjoying
Sir,
physics.
sir, I have this one small doubt. I will ask you in the WhatsApp if it's fine. It's
Ask now
possible.
only. DMs are like I'm telling you, I have like
Okay.
300-400 DMs. Like I don't know. It's just
No,
disappears.
sir,
I
it's
cannot.
not at all related to this topic. So it's basically like, say for example, I want to take architecture in the future because you said you did do architecture.
Okay.
So what all do I have to study? Like what all do I have to study on the subjects?
Okay, so one thing is that there's this course called engineering drawing.
Okay.
Okay, you have to take that course up in 11th and 12th. Okay, in your school. We'll not be doing coaching for that, but the rest of the preparation remains same. It's just that you have to have engineering drawing, and you should also have a little bit of I don't know, a creative side of things that makes it slightly easier in the architecture field. My mom is an architect, so I know she's very
Okay.
creative.
So what do you mean by engineer drawing or whatever that was that course?
There's a course in 11th and 12th that says engineering that whose name is engineering. So PCM,
Yeah.
and the fourth subject you can take computer science, you can take music. I took painting, and then you can take engineering drawing. This is a subject either you have to study on your own, or second you take up that course and that instructor will teach you. So if your school has a provision for engineering drawing, please take it up because it will help you in architecture.
So
Okay.
unfortunately, I already took up computer science. I was just asking.
Yes, please ask for engineering drawing if they have that engineering drawing. Otherwise, you might have to take up an external course to learn about engineering drawing.
So I believe ITPL has engineering drawing though.
I don't know. I am not dealing with anything other than PCM. I have no clue about what
Okay.
ITPL does. So because I've been associated with ITPL only for a year now, so
Okay.
I know students have taken entrepreneurship. I think there is this psychology is also there.
Yeah,
Yes.
yeah, psychology is there.
Yes, and I think there's one more. Computer science. Yeah, computer science is there. Yeah, that's pretty much it. I think these are the three options there. So
Okay.
if you're from ITPL, then you might have to take up an external course on engineering.
Okay. So will you be teaching that course?
Engineering drawing, no. Yeah, wish
Okay.
I can, but it's not a course that I usually take. Okay.
Okay.
I'll give you. When we meet, I'll give you links to that course. It's easily available on the nowadays. There's a lot of online platform to learn. So
Yeah,
it's
yeah.
just you should know. You should have that greed to learn. If you want, then you can learn anything nowadays. So
Okay.
yeah, take up that course. Do some basic architectural courses. Like if you want to stay ahead of the curve. But people usually just go in with some little bit of preparation. But if you do extra hard work, then you can reach probably the best colleges in architecture. Okay, it's a very good line.
Okay. Okay, sir.
Okay, take care,
Thank you,
guys.
sir.
I'll see you next time.
Yes, sir. Thank
Any
you,
other
sir.
doubt?
Thank you, sir.
Thank you, sir.
Mm.